Docker and DevOps collaborate for efficient software development. Docker ensures consistency and portability, while DevOps focuses on teamwork, automation, and CI/CD, resulting in faster development and deployment. In this Docker Complete course, we will cover Docker basics, installation on Ubuntu and Windows 10, advanced concepts, containerization, and more. We will compare Docker with Kubernetes and virtual machines and end with Docker interview questions. So if you are looking to become a Docker expert, consider the postgraduate program in DevOps by Simplilearn to gain expertise in Docker. This program offers blended learning that combines live online DevOps certification classes with interactive labs that will give you hands-on experience. You will gain expertise in the tools like Terraform, Maven, Ansible, Jenkins, Docker, JUnit, Git, and more. We prefer 1 year of prior experience to enroll in this course. So why wait? Enroll the course from the link in the description box. So before we begin, consider subscribing to Simplilearn and hit the bell icon to never miss any updates from us. So without any further delay, over to our tutors.
DevOps engineers are one of the highest paid professionals in the tech industry today. And if you are watching this video, most likely you are someone who wants to get into DevOps or want to learn DevOps. But with so many different tools and technologies like Terraform, Ansible, Linux, AWS, Jenkins, Docker, Kubernetes, and so much more, learning DevOps can be very time consuming and confusing. And that is why in this video, I'm going to share with you a complete DevOps roadmap that you can follow to learn DevOps from scratch, and also an excellent resource you can use to learn all these DevOps tools at one place. So watch this video till the end. Before we start with the video and look into the DevOps roadmap, let me introduce myself. My name is Nasiullah Chaudhary, also goes by CloudChamp on YouTube, and I work as a freelance DevOps engineer for multiple companies. The roadmap shared in this video is the exact roadmap I followed to learn DevOps from scratch, and I'm pretty sure if you watch this video till the end, you will have a clear idea on what things to learn and what not to learn and get jobs faster. A DevOps engineer is responsible for deploying application and automating the manual process. But how can you automate a manual process if you don't know how is an application created? So first thing you need to know is to understand the concepts of software development. What is a build? What is software deployment? So generally try to understand the whole software development lifecycle from idea to code and to releasing the application to end users. After you understand the software development lifecycle and now you have an idea of how is an application created, second thing you need to know is Linux. Linux is very, very, very important. A DevOps engineer should have a good hands-on knowledge with Linux, need to know all the important commands, because every DevOps tools you look at, let's say Ansible, Terraform, Kubernetes, Docker, all of them work on commands, and you can only manage to work with them when you have good hands-on knowledge with Linux. So learn Linux. In Linux, you can learn things like shell commands, Linux file systems and permissions, SSH key management, virtualization, some part of networking like load balancers, how to set up firewalls, how IP addresses work, and much more. Linux is very important, so it's also called as operating system of the cloud. So spend time learning Linux. Now, most of you might be confused and you might ask, let's say I want to learn all these tools, but where should I find the resources? You can learn this from YouTube, some of these from blogs, some from document. Next important thing after learning Linux is going to be Git, because every company is going to store their code online on Git repositories like GitHub, GitLab, or Bitbucket. So our DevOps engineers need to know how to work with Git to clone and push the code from local machine to Git repositories or from Git repositories to local machine. Also understand what is branching, how does branching works, what is merge request, what is pull request, and a lot more. So a DevOps engineer should have a good understanding of Git and also know all the most used Git commands. Once you have cleared your basics, now is the time to learn cloud, because DevOps engineers need to know how to create servers, databases, storage, virtual VPCs, and lot more on the cloud. You can choose any cloud like AWS, Azure, GCP, IBM, Oracle, or anything. But DevOps engineers need to know how to create infrastructure to deploy their applications and software on the cloud. Once you have learned how to create infrastructure and deploy your applications on the cloud manually, you need to automate this, because DevOps is all about automation. So you can automate this using infrastructure as code tools like Terraform, Ansible, Chef, Puppet, and a lot more. But I would suggest you learning only these two tools, which are Terraform and Ansible, that are highly used in the industry today. Learning Ansible and Terraform can provide you with so many job opportunities. So start with learning Terraform and Ansible after you have mastered creating an application on the cloud manually. Due to rise in demand and application stability, companies are shifting from servers to containers, which is why you need to learn Docker and Kubernetes. For Docker, you need to understand the concepts of virtualization and concept of containerization. Also, you need to know how to containerize an application and run it on a server or a Kubernetes cluster. You need to know the commands on how to create Docker file, how to create Docker image, how to run containers, networking in Docker, and some of the parts. For Kubernetes, you need to understand the Kubernetes architecture, what is deployment, what is replica set, what is pod, what is node, and how to properly manage a containerized application using Kubernetes cluster, either on EKS, AKS, or GKE, which is going Kubernetes engine. So it is very important for you to understand and know the commands to properly work through containerization, which is a leading and a popular tool right now in the market. Next, very important thing for a DevOps engineer to learn is going to be CI/CD, or continuous integration and continuous deployment, because every company wants to deploy their application automatically. In DevOps, all code changes like new features or bug fixes should be integrated in the existing application and provided to the end user in an automated fashion. And you can only do this by using CI/CD. So a DevOps engineer should know how to set up CI/CD server, how to integrate code repositories to trigger pipeline automatically when there is a change, and to fix bug faster, and to provide better quality software to the end user very fast in automated fashion. Some popular CI/CD tool includes Jenkins, GitLab, Circle CI, Travis CI. So learning CI/CD will help you land your job very, very fast, and it's very important, also known as heart of DevOps. So you should master CI/CD. All the tools that we have mentioned till now will help you deploy an application on the cloud or on containers anywhere. But once the software or your application is in production, it is very important for you to monitor it, to track performance, to see if there are any issues, check system resources like CPU or RAM or anything. So one of the responsibilities of DevOps engineer is to set up software monitoring, infrastructure monitoring, collect logs, and to visualize data to check if there are any issues or if system has less resources or not. So you need to learn tools like Prometheus, Grafana, also logging tools like CloudWatch or ELK Stack, which is very important to make sure that an application is running without any issues and without any problems. Congratulations, now you know all the tools and technologies you require to become a DevOps engineer. But DevOps is all about automation, and there is always going to be something that you can automate. So to automate this, you will require scripting language. And some of you might argue that scripting is not required, or you don't need any programming language in DevOps. Coding is not a thing in DevOps, but that's not actually true. You will require knowledge of one programming language or a scripting language, because you need to automate the manual process. So some popular scripting language can be Bash, PowerShell, which are all OS related. So you can use Bash in Linux, in PowerShell in Windows. And non-OS related are Python, Go, Ruby, which is what I would suggest. I would suggest you trying to learn Python, which will help you automate all the manual process, like rotating passwords of your databases, like starting a deployment, starting a build, or clearing cache. Anything that you are doing manually can be automated through scripting languages using this Python or Go or Bash. My suggestion would be to start with Python. And if you learn Python, you will be unstoppable and you will have more value as a DevOps engineer. And you don't need to learn any programming language at a software engineer level. You just need to know enough Python or enough Go just to write scripts which can automate your things. You don't need to go deep in DSA and all those things, which are very common questions that I get. So just focus on learning Python in a way where you can automate things by writing scripts. So just the basics, not too advanced, only to automate stuff. So there you have it, a complete DevOps roadmap to learn things from scratch. Along with this, make sure you have your LinkedIn perfect, you attend meetups, and also enroll to the Simplilearn DevOps program.
The field of DevOps has grown exponentially over the past few years, and it's no surprise why. DevOps is a set of practices and tools that aims to break down the silos between development and operations team and streamline the software delivery process. By doing so, DevOps enables organizations to deliver high-quality software faster and more efficiently than ever before. So if you're interested in pursuing a career in DevOps, then this video on how to choose DevOps as a career is for you, with the proper roadmap on how to get started with it. Also, do not forget to subscribe to our YouTube channel and hit the bell icon to never miss an update from Simplilearn. So without any further ado, let's get started. First is to understand the role of a DevOps professional. Before diving into the specifics of how to become a DevOps professional, it's essential to understand the roles and responsibilities of a DevOps professional. A DevOps professional is typically responsible for designing, implementing, and maintaining the infrastructure, automation tools, and processes required for the efficient delivery of software. This includes collaborating with development teams to integrate automation into the software development process, setting up and maintaining the infrastructure required for the software delivery pipeline, such as servers, databases, and network systems, developing and implementing automation scripts to improve the efficiency of software delivery process, continuously monitoring and analyzing the software delivery process to identify and resolve bottlenecks and improve efficiency, ensuring that the software delivery process adheres to industry best practices and regulatory requirements. So now that you understand the roles and responsibilities of a DevOps professional, let's take a look at the roadmap to become a DevOps professional. So first is to learn the basics of software development. To be an effective DevOps professional, it's essential to have a good understanding of software development processes, including programming languages, software development methodologies, and version control tools. Following that, learn about infrastructure and operations as a DevOps professional. You will be responsible for managing infrastructure, including servers, databases, and network system. So it's essential to have a good understanding of infrastructure and operations. This includes learning about servers, operating systems, network protocols, and storage systems. Then explore about automation tools and cloud services. Automation is a critical part of DevOps. Learning automation tools such as Ansible, Puppet, or Shift can help you streamline the software delivery process and improve efficiency. Most organizations today use cloud services to deliver software. Learning cloud services such as AWS, Azure, or GCP can help you design and implement cloud architecture that are efficient and scalable. Well, to help you with learning DevOps and cloud services, Simplilearn has to offer Azure DevOps Solution Expert Master's Program to help you become an industry-ready professional. In this course, you will learn to plan smarter, collaborate better, and ship faster with a set of modern development services. The link for this course is mentioned in the description. Do check them out. Once done with skilling, you need to gain experience and get certified as discussed before. The best way to gain experience in DevOps is to work on real-world projects. This can be achieved through internships, volunteering for open source projects, or even taking on small projects on your own. This will allow you to put your theoretical knowledge into practice and gain hands-on experience. Along with it, there are various certification programs available, such as the DevOps Institute Certification Program, AWS Certification DevOps Engineer, and Microsoft Azure DevOps Solutions Certification. Once you have gained experience and acquired the necessary skills, it's time to start looking for job opportunities. There are various job titles in DevOps, such as DevOps Engineer, Site Reliability Engineer, Automation Engineer, and Release Engineer. In top hiring companies in the field include Amazon, Google, Microsoft, IBM, and many others.
In today's fast-paced and ever-evolving world of software development, DevOps has emerged as a transformative approach, bridging the gap between development and operations team. DevOps tools are pivotal in streamlining the software delivery process, fostering collaboration, and empowering organizations to achieve continuous integration, deployment, and delivery. Here we present a curated list of top DevOps tools that have revolutionized the industry. The power of these DevOps tools lies in their ability to enhance productivity, scalability, and reliability, enabling organizations to deliver high-quality software faster and with confidence. From version control systems like Git and Subversion to containerization platforms like Docker and Kubernetes. From configuration management tools like Ansible and Puppet to monitoring and logging tools like Prometheus. Every tool in every step fosters seamless software development and deployment, ensures system health, and provides valuable insights for troubleshooting. In this DevOps Tools tutorial, we will learn the top DevOps tools you must focus on to become a successful DevOps professional. If these are the types of videos you would like to watch, then hit the subscribe button, like, and press on the bell icon to never miss any further content. Now, over to our training experts.
Hello everyone. Without further ado, let's get started. Before diving into the tools, let's briefly summarize the DevOps phases. DevOps phases are a series of interconnected steps that streamline software development and deployment. Here's a crisp explanation of each stage. First, plan. Define project goals, requirements, and milestones. Plan takes prioritized work and establish a roadmap for development. Next is code. Developers write and review code collaboratively using version control systems to manage changes and ensure code quality. The third one is build. Convert the code into executable software components, including compiling, linking, and packaging the code base. Fourth step, testing. Automated testing is performed to validate the software's functionality, performance, and security. And this includes unit testing, integration tests, and system tests. The fifth stage is the release stage. Prepare the software for deployment by finalizing features, documentation, and versioning. Ensure all necessary approvals and compliance requirements are met. Sixth one, deploy. Move the software to target environment, whether it is on-premises or the cloud. This involves setting up infrastructure, configuring resources, and installing the software. Now, the seventh one, operate. Manage the software and infrastructure in a production environment. Monitor system health, address operational issues, and ensure smooth functioning. The eighth one is monitoring phase. Continuously monitor the software's performance, availability, and security. Collect metrics, analyze logs, and identify and resolve any anomalies or bottlenecks. These stages form a continuous loop, allowing for iterative development, rapid feedback, and continuous improvement. DevOps enhances collaboration, automation, and efficiency throughout the software development lifecycle by integrating development and operations team. Now, let's discuss the tools, the primarily used and prominent ones in each phase, starting with planning. Jira and Trello are the most popular tools. Jira is a popular project management tool that helps teams in planning phase of DevOps. It enables teams to create and manage tasks, track progress, and allocate resources. Trello. Trello is a visual collaboration tool that simplifies project planning and organization. It provides a flexible and intuitive interface where teams can create boards, lists, and cards to represent tasks, workflows, and milestones. These tools provide teams with the necessary functionalities to plan, organize, and track tasks, ensuring clarity, transparency, and alignment of planning phase of DevOps projects. Now, proceeding ahead, we will discuss about the next phase, which is the coding phase. The important tools here are Git, Visual Studio. Firstly, Git. Git is a widely used distributed version control system that plays a crucial role in coding phase of DevOps. It allows developers to track changes to their database, collaborate on code with teammates, and easily manage different versions of their software. Now, the Visual Studio Code. Visual Studio Code is a lightweight, versatile code editor that provides a rich set of features for developers. It supports various programming languages, syntax highlighting, debugging, and integrated terminal, making it a popular choice for coding in the DevOps context. These tools, Git, VS Code, provide developers with the necessary infrastructure and capabilities to manage code efficiently, collaborate effectively, and ensure code quality during the coding phase of DevOps projects. Now, let's proceed to the next phase, which is the build phase. We have Jenkins, Gradle, and Maven in this particular segment. Firstly, Jenkins. Jenkins is a widely used open source automation server that plays a crucial role in the build phase of DevOps. It enables teams to automate the build, test, and deployment process, facilitating continuous integrity and delivery. Now, the Gradle. Gradle is a powerful build automation tool that provides a flexible and scalable framework for building and managing software projects. It supports multiple programming languages and offers advanced features like dependency management, incremental builds, and parallel execution. And lastly, Maven. Maven is a popular build management tool that simplifies project setup, dependency management, and build processes. It uses a declarative XML-based configuration and follows conventions over configuration principles. These tools empower teams in the build phase of DevOps by automating the compilation, packaging, and distribution of software. They streamline the build process, ensure code quality, and facilitate efficient integration with other stages of DevOps pipeline. Now, we will discuss the testing phase. We have three most popular testing tools: Selenium, JUnit, and Postman. First, Selenium. Selenium is a widely used open source framework for automating web browser testing. It allows teams to write and execute automated tests across different browsers and platforms, ensuring consistent functionality and user experience. Next, we have JUnit. JUnit is a popular testing framework for Java applications. It provides a simple and standardized way to write and execute a unit test, allowing developers to verify the correctness of individual code units. And lastly, Postman. Postman is a powerful API testing and collaboration platform. It allows teams to design, build, and automate tests for RESTful API services, ensuring their functionality, performance, and security are integrated. Postman provides an intuitive interface for creating and organizing test cases, making API requests, and validating responses. Now, these tools aid in the test phase of DevOps by automating and simplifying the testing process. They facilitate efficient testing of web applications, unit testing of code units, and comprehensive testing of APIs, ensuring software quality and reducing the risk of bugs and issues in production environment. Proceeding ahead, we have the release phase. Ansible, AWS Code Deploy are the most popular release tools. Ansible is a powerful open source automation tool that helps teams automate the release phase of DevOps. It allows for easy configuration management, deployment, and orchestration of software releases. Next, AWS Code Deploy. AWS Code Deploy is a fully managed deployment service provided by Amazon Web Services. It simplifies the release phase by automating application deployments to a variety of compute environments. These tools assist teams in release phase of DevOps by automating deployment process, ensuring consistent and reliable releases, and simplifying configuration management. Now, we are in the deployment phase. Docker, Kubernetes, and AWS Elastic Beanstalk are the popular deployment tools. Firstly, Docker. Docker is a popular containerization platform that simplifies the deployment phase in DevOps. It allows teams to package applications and their dependencies into lightweight, portable containers. Docker provides a consistent and isolated environment for running applications, enabling seamless deployment across different infrastructures. Next, we have Kubernetes. Kubernetes is an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It provides a robust framework for managing clusters of containers across multiple nodes. Followed by that, we have the Elastic Beanstalk. AWS Elastic Beanstalk is a fully managed platform as service provided by Amazon Web Services. It simplifies the deployment phase by abstracting the underlying infrastructure and providing the easy-to-use platform for deploying and managing applications. These tools play a vital role in deployment phase of DevOps by automating application deployment, ensuring scalability, and simplifying infrastructure management. Next, we will be taking care of operate phase. Prometheus, Elasticstack, PagerDuty are the popular operate tools. Firstly, Prometheus. Prometheus is an open source monitoring and alerting tool widely used in operate phase. It collects metrics from various systems, services, and applications, allowing tools to monitor performance, availability, and resource utilization. Next, we have Elasticstack or ELK-Stack. ELK-Stack is also known as Elasticsearch, Logstash, and Kibana, which is a powerful combination of open source tools used for log management and analysis in the operate phase. Elasticsearch stores the indexes log data, Logstash collects and processes logs, and Kibana provides a user-friendly interface for searching, analyzing, and visualizing log data. Now, the PagerDuty. PagerDuty is an incident management platform that helps teams in the operate phase of DevOps to respond and resolve incidents quickly. It provides a real-time alerting, on-call schedules, and escalation policies, ensuring that the right team members are noticed and engaged during incidents. Now, these tools are instrumental in the operate phase of DevOps by providing monitoring, log management, and incident response capabilities. And finally, we have the monitoring phase. Nagios and Grafana are the most popular monitoring tools. Firstly, we will have a discussion about the Nagios. Nagios is a widely used open source monitoring tool that plays a crucial role in monitoring phase of DevOps. It enables teams to monitor the health and performance of their systems, applications, and network infrastructure. Next, we have Grafana. Grafana is also one of the popular data visualization and analytics tool commonly used in monitor phase of DevOps. It integrates with various data sources, including monitor systems and databases, to create visually appealing and interactive dashboards. These tools are essential in monitoring phase of DevOps as they provide the necessary capabilities and monitoring, visualization, and analysis of system performance, metrics, and logs. They enable teams to proactively monitor and optimize their applications and infrastructure, ensuring optimal performance, availability, and user experience. And with that, we have finished the top DevOps tools in 2023.
So let's take a little scenario of a developer and a tester before you had the world of Docker. a developer would actually build their code and then they send it to the tester, but then the code wouldn't work on their system. The code doesn't work on the other system due to the differences in computer environments. So what could be the solution to this? Well, you could go ahead and create a virtual machine to be the same as the solution in both areas. But we think Docker is an even better solution. So let's kind of break out what the main big differences are between Docker and virtual machines. As you can see between the left and the right hand side, both look to be very similar. What you'll see, however, is that on the Docker side, what you'll see as a big difference is that the guest OS for each container has been eliminated. Docker is inherently more lightweight, but provides the same functionality as a virtual machine. So let's step through some of the pros and cons of a virtual machine versus Docker. So first of all, a virtual machine occupies a lot more memory space on the host machine. In contrast, Docker occupies significantly less memory space. The boot up time between both is very different. Docker just boots up faster. The performance of the Docker environment is actually better and more consistent than the virtual machine. Docker is also very easy to set up and very easy to scale. The efficiencies, therefore, are much higher with a Docker environment versus a virtual machine environment. And you'll find it is easier to port Docker across multiple platforms than a virtual machine. Finally, the space allocation between Docker and a virtual machine is significant. When you don't have to include the guest OS, you're eliminating a significant amount of space, and the Docker environment is just inherently smaller. So after Docker, as a developer, you can build out your solution and send it to a tester. And as long as we're all running in the Docker environment, everything will work just great. So let's step through what we're going to cover in this presentation. We're going to look at the DevOps tools and where Docker fits within that space. We'll examine what Docker actually is and how Docker works. And then finally, we'll step through the different components of the Docker environment. So what is DevOps? DevOps is a collaboration between the development team and the operation team, allowing you to continuously deliver solutions and applications and services that both delight and improve the efficiency of your customers. If you look at the Venn diagram that we have here, on the left-hand side we have development, on the right-hand side we have operation, and then there's a crossover in the middle, and that's where the DevOps team sits. If we look at the areas of integration between both groups, developers are really interested in planning, code, building, and testing, and operations want to be able to efficiently deploy, operate, and monitor. When you can have both groups interacting with each other on these 7 key elements, then you can have the efficiencies of an excellent DevOps team. So planning and codebase, we use tools like JIT and Gira. For building, we use Gradle and Maven. Testing, we use Selenium. The integration between dev and ops is through tools such as Jenkins. And then the deployment operation is done with tools such as Docker and Chef. Finally, Nagios is used to monitor the entire environment. So let's step deeper into what Docker actually is. So Docker is a tool which is used to automate the deployment of applications in a lightweight container so the application can work efficiently in different environments. Now, it's important to note that the container is actually a software package that consists of all the dependencies required to run the application. So multiple containers can run on the same hardware. The containers are maintained in isolated environments. They're highly productive and they're quick and easy to configure. So let's take an example of what Docker is by using a house that may be rented for someone using Airbnb. So in the house, there are 3 rooms and only 1 cupboard and kitchen. And the problem we have is that none of the guests are really ready to share the cupboard and kitchen because every individual has a different preference when it comes to how the cupboard should be stocked and how the kitchen should be used. This is very similar to how we run software applications today. Each of the applications could end up using different frameworks. So you may have a framework such as Rails, Perfect, and Flask, And you may want to have them running for different applications for different situations. This is where Docker will help you run the applications with the suitable frameworks. So let's go back to our Airbnb example. So we have 3 rooms and a kitchen and cupboard. How do we resolve this issue? Well, we put a kitchen and cupboard in each room. We can do the same thing for computers. Docker provides the suitable frameworks for each different application. And since every application has a framework with a suitable version, this space could also then be utilized for putting in software and applications that along. And since every application has its own framework and suitable version, the area that we had previously stored for a framework can be used for something else. Now we can create a new application, in this instance a 4th application that uses its own resources. You know what? With these kinds of abilities to be able to free up space on the computer, it's no wonder Docker is the right choice. So let's take a closer look to how Docker actually works. So when we look at Docker and we call something Docker, we're actually referring to the base engine, which actually is installed on the host machine that has all the different components that run your Docker environment. And if we look at the image on the left-hand side of the screen, you'll see that Docker has a client-server relationship. There is a client installed on the hardware. There is a client that contains the Docker product, and then there is a server which controls how that Docker client is created. The communication that goes back and forth to be able to share the knowledge on that Docker client relationship is done through a REST API. And this is fantastic news because that means that you can actually interface and program that API. So we look here in the animation, we see that the Docker client is constantly communicating back to the server information about the infrastructure, and it's using this REST API as that communication channel. The Docker server then will check out the requests and the interaction necessary for it to be the Docker daemon, which runs on the server itself, will then check out the interaction and the necessary operating system pieces needed to be able to run the container. Okay, so that's just an overview of the Docker engine, which is probably where you're going to spend most of your time. But there are some other components that form the infrastructure for Docker. Let's dig into those a little bit deeper as well. So what we're going to do now is break out the 4 main components that comprise of the Docker environment. The 4 components are as follows: the Docker client and server, which we've already done a deeper dive on, Docker images, Docker containers, and the Docker registry. So if we look at the structure that we have here, on the left-hand side, you see the relationship between the Docker client and the Docker server. And then we have the REST API in between. Now, if we start digging into that REST API, particularly the relationship with the Docker daemon on the server, we actually have our other elements that form the different components of the Docker ecosystem. So the Docker client is accessed from your terminal window. So if you are using Windows, it's going to be PowerShell. On Mac, it's going to be your terminal window. And it allows you to run the Docker daemon and the registry service. When you have your terminal window open, so you can actually use your terminal window to create instructions on how to build and run your Docker images and containers. If we look at the images part of our registry here, we actually see that the image is really just a template with the instructions used for creating the containers which you use within Docker. The Docker image is built using a file called the Docker file. And then once you've created that Docker file, you'll store that image in the Docker Hub or registry. And that allows other people to be able to access the same structure of a Docker environment that you've created. The syntax of creating the image is fairly simple. It's something that you'll be able to get your arms around very quickly. And essentially what you're doing is you're creating the option of a new container. You're identifying what the image will look like, what are the commands that are needed, and the arguments for within those commands. And once you've done that, you have a definition for what your image will look like. So if we look here at what the container itself looks like, is that the container is a standalone executable package which includes applications and their dependencies. It's the instructions for what your environment will look like. So you can be consistent in how that environment is shared between multiple developers, testing units, and other people within your DevOps team. Now, the thing that's great about working with Docker is that it's so lightweight that you can actually run multiple Docker containers in the same infrastructure and share the same operating system. This is its strength. It allows you to be able to create those multiple environments that you need for multiple projects that you're working on. Interestingly though, within each container, that container creates an isolated area for the applications to run. So while you can run multiple containers in an infrastructure, each of those containers are completely isolated. They're protected so that you can actually control how your solutions work there. Now, as a team, you may start off with 1 or 2 developers on your team, but when a project starts becoming more important and you start adding in more people to your team, you may have 15 people that are offshore, you may have 10 people that are local, you may have 15 consultants that are working on your project. You have a need for each of those developers or each person on your team to have access to that Docker image. And to get access to that image, we use the Docker registry, which is an open source server-side service for hosting and distributing the images that you have defined. You can also use Docker itself as its own default registry and Docker hub. Now, something that has to be very in mind though is that for publicly shared images, you may want to have your own private images, in which case you would do that through your own registry. So once again, public repositories can be used to host the Docker images, which can be accessed by anyone. And I really encourage you to go out to Docker and see the other Docker images that have been created, because there may be tools there that you can use to speed up your own development environments. Now, you will also get to a point where you start creating environments that are very specific to the solutions that you are building. And when you get to that point, you'll likely want to create a private repository so you're not sharing that knowledge with the world in general. Now, the way in which you connect with the Docker registry is through simple pull and push commands that you run through terminal window to be able to get the latest information. So if you want to be able to build your own container, what you'll start doing is using the pull commands to actually pull the image from the Docker repository. And the command line for that is fairly simple. In terminal window, you would write docker pull, and then you put in the image name and any tags associated with that image and use the command pulls. So in your terminal window, you would actually use a simple line of command once you've actually connected to your Docker environment. And that command will be docker pull with the image name and any associated tags around that image. What that will then do is pull the image from the Docker repository, whether that's a public repository or a private one. Now, in reverse, if you want to be able to update the Docker image with new information, you do a push command where you would take the script that you've written about the Docker container that you define and push it to the repository. And as you can imagine, the commands for that are also fairly simple. In terminal window, you would write docker push the image name, any associated tags, and then that would then push that image to the Docker repository. Again, either a public or a private repository. So if we recap, the Docker file creates a Docker image that's using the build commands. A Docker image then contains all of the information necessary for you to be able to execute the project. Using the Docker image, any user can run the code in order to create a Docker container. And once a Docker image is built, it's uploaded to a registry or to a Docker hub where it can be shared across your entire team. And from the Docker hub, users can get access to the Docker image and build their own new containers. So the 5 key takeaways here. So with a virtual machine, you're able to create a virtualized environment to run an application on an operating system. With Docker, it allows you to focus on just running the application and doing it consistently. It improves the ability for teams to be able to share environments that are consistent from team to team. It's highly productive and it's really quick and easy to configure. The architecture of Docker is really primarily built out of 4 components, of which the one that you'll use the most is the client server environment, where as a developer you have a client application running on your local machine, and then you connect with a server environment where you're getting the latest information about that container that you're building a solution for. And then finally, what we see with the workflow improvements with Docker is that the goal is to be able to be more efficient, to be able to be more consistent with your development environments, and be able to push out those environments, whether it goes to a test person, to a business analyst or anybody else on your DevOps team so they have a consistent environment that looks and acts exactly like your production environment and can be eventually pushed out to a production environment using tools such as Puppet or Chef, so you're creating a consistent operations environment.
So before we begin, let me give you an intro to Docker. So what is Docker? Docker is a tool which is used to automate the deployment of applications in lightweight containers. So when I say containers, I mean a software package that consists of all the dependencies required to run the particular application. And when you deploy containers, you're basically providing the capability for the application to run in any kind of environment. So Dockers have multiple features, some of which are that multiple containers can run on the same hardware. It has very high productivity when compared to virtual machines. It maintains isolated applications and has a very quick and easy configuration process. So now let's begin with the demo. We'll be installing Docker on an Ubuntu system. So this is my system. I'll just open the terminal. So the first thing you can start with is removing any Docker installation that you probably already have present in your system if you want to start from scratch. So this is the command to do so. Sudo apt-get remove docker docker engine docker.io. Enter your password and Docker is removed. So now we'll start from scratch and we'll install Docker once again. Before that, I'll just clear my screen. Okay, so before I install Docker, let me just ensure that all the softwares on my system currently is in its latest state. So sudo apt-get update. Great, so that's done. Next thing, we'll actually install our Docker. So type in sudo apt get install Docker. Now as you can see here, there's an error that's occurred. So sometimes it's possible that due to the environment of the machine that you're working in, this particular command does not work. In which case, there's always another command that you can start with. Just type docker install. And that by itself will give you the command you can use to install Docker. So as it says here, sudo apt install docker.io is a command that we will need to execute to install Docker. And after that, we'll execute the sudo snap install Docker. So sudo apt install docker.io first. And this will install your Docker. After that's done, we will have sudo snap install Docker. So snap install Docker installs a newly created snap package. They are basically some other dependencies for Docker that you'll have to install. Of course, since this is the installation process for the entire Docker IO, it will take some time. Great, so our Docker is installed. The next thing we do, as I mentioned earlier, is that we need to install all the dependency packages. So the command for that is sudo snap install Docker. Enter your password So with that, we have completed the installation process for Docker, but we'll perform a few more stages where we will test if the installation has been done right. So before we move on with the testing for Docker, let's once again just check the version that we have installed. So for that, the command is docker version, and as you can see, Docker version 17.12.1 CE has been installed. Next thing we do is we pull an image from the Docker hub. So docker run hello world. Now hello world is a Docker image which is present on the Docker hub. Docker hub is basically a repository that you can find online. So with this command, the Docker image hello world has been pulled onto your system. So let's see if it's actually present on your system now. The command to check this is sudo docker images. And as you can see here, hello world repository, this is present on our system currently. So the image has been successfully pulled onto the system, and this means that our Docker is working. Now we'll try out another command. Sudo docker ps -a. This displays all the containers that you have pulled so far. So as you can see here, there are 3 hello world images displayed, and all of them are in exited state. So I did this demo previously too, which is why the 2 hello worlds which is created 2 minutes ago is also displayed here. And the first hello world which has been created a minute ago is the one we just did for this demo. Now, as you have probably noticed that all the hello world images over here, all these containers are in the exited state. So when you give the option for docker ps -a, where -a stands for all, it displays all the containers whether they are in exited or running state. If you want to see only those containers which are in their running state, you can simply execute sudo docker ps. Sudo docker ps. And as you can see, no container is visible here because none of them are in running state. And with that, we come to an end of our Docker installation.
Now, Docker is something which is available for most of the operating systems, different platforms. So it supports both the Unix and the Windows platform as such. So Linux, through various commands, we can do the installation. But in the case of Windows, you have to download the exe file and a particular installer from the Docker Hub websites. You can simply Google it and you will get a kind of link from where you will be able to download the package. So let's go to the Chrome and try to search on for the Windows String particular installer. You will get a link from Docker Hub. You download it, you get the stable version, you get the edge version, whichever version you wish to download, you can download it. So let's go back to the Chrome. So here you have the Docker desktop for Windows, so you can go for the stable or you can go for the edge, right? So you also have the comparison that what is the difference between these two versions, right? So the particular edge version is something which is getting releases every month, and the stable version is getting the releases every quarter. So they are not doing much of the changes to the stable version as compared to the edge there. So you just have to double click on the installer and that will help you to do the installation of the process. So let's get started. So you just click on the get in stable version. So when you do that, the particular installer is going to install. Now it's going to take like around 300 MB there. So that's the kind of installer which is available. So once the installer is downloaded, so what you can do is that you can actually go ahead and you can proceed with doing the double click on this installer. When you double click on that, you have to proceed with some of the steps, like from the GUI itself you are going to proceed with these steps. So we'll wait for 10 to 20 seconds more and then the installer will be done, and then we can do the double click and the installation will proceed. So another thing is that there is a huge difference between the installer. Like for example, in case of Unix, the installer is a little bit less, but in case of Windows, it's a GUI is also involved, and there are a lot of binaries which is available there. So that's the reason why the huge size is there.
Now it's available for free, that's for sure, and it also requires the Windows 10 Professional or Enterprise 64-bit there. So if you are working on some previous version of operating systems like Windows 7 and all, you have the older version called Docker Toolbox. So they used to call it as like Docker Toolbox earlier, but now they are calling it as a Docker Desktop with the new Docker Windows 10 support as such here. So another couple of seconds and then the installer will be done, and then we will be able to proceed with the installation. So let's see that how much progress is there to the download. So we'll click on the downloads, and here still we have some particular installations or some download going on. So we'll wait for some time, and once the installation is done, then we'll go back and we'll proceed with installation. So couple of seconds. So it's almost done. So I'll just click on this one. You can go to the directory, to the downloads, and you can double click on that also. But if you want to do the installation, you can click on this one also, and it will ask for the approval, yes or no you have to provide. Now once that is done, so a desktop, a kind of a GUI component will open there. So it will start proceeding with the installation. So it's asking whether you want to add a desktop, the shortcut to desktop. So you can say okay. I'm going to click on OK. So it will unpack the files, all the files which is required for Docker to successfully install, that is getting unpacked over here. So it will take some time to do the installation because it's doing a lot of work here. So you can just wait for till the execution of the installer to be completed, and once the installer is done, you can open your command line and start working on the Docker. So taking some time to extract the files. Now it's asking us to do the close and do the restart. So once that is done, you will be able to proceed further, and you can just run the command line, and any Docker command if you can run, so that will give you the response whether the Docker is installed or not. So you can see here that Docker is something which is installed, so you can run like Docker version. You will be able to get a version of the client. When you do the restart of the machine, then at that moment of time the Docker server will also be started, and then this particular error message will go off. Right now the Docker daemon is not up and running because the installation requires a restart, and when you close on this one and go for the restart, the machine will be restarted here. So this is the way that how exactly we can go for a Docker installation, and we can go on that part.
So if you are looking to become a Docker expert, consider the postgraduate program in DevOps by Simplilearn to gain expertise in Docker. This program offers blended learning that combines live online DevOps certification classes with interactive labs that will give you hands-on experience. You will gain expertise in the tools like Terraform, Maven, Ansible, Jenkins, Docker, JUnit, Git, and more. We prefer 1 year of prior experience to enroll in this course. So why wait? Enroll the course from the link in the description box.
So let's look at some of the more advanced concepts within the Docker environment. And we're going to look at two advanced components. One is Docker Compose, and the second is Docker Swarm. So let's look at Docker Compose. Docker Compose is really designed for running multiple containers as a single service, and it does this by running each container in isolation but allowing the containers to interact with each other. As was stated earlier on, you would actually write the Compose environment using YAML as the language in the files that you would create. So where would you use something like Docker Compose? So an example would be if you are running an Apache server with MySQL database and you need to create additional containers to run additional services without the need to start each one separately. And this is where you would write a set of files using Docker Compose to be able to help balance out that demand. So let's now look at Docker Swarm. So Docker Swarm is a service that allows you to be able to control multiple Docker environments within a single platform. So what you actually are looking at doing is within your Docker Swarm is we're treating each node as a Docker daemon, and we're actually having an API that's interacting with each of those nodes. There are two types of node that you're going to be getting comfortable working with. One is the manager node, and the second is the worker node. And as you'd expect, the manager node is the one sending out the instructions to all of the worker nodes. But there is a two-way communication that is happening. The communication allows for the manager node to be able to manage the instructions and then listen to and receive updates from the worker node. So if anything happens within this environment, the manager node can react and adjust the architecture of the worker node so it's always in sync. It was really great for large scaled environments. So finally, let's go through what are some of the basic commands you'd use within Docker. And once we've gone through all these basic commands, we'll actually show you a demo of how you'd actually use them as well. So if we're going to go in, probably the first command is to install Docker. And so if you have yum installed, you just do yum install Docker and you'll install Docker onto your computer. To start the Docker daemon, as you want to do systemctl start Docker. The command to remove a Docker image is docker rmi and then the image ID itself. And that's not the image name, that's the actual alphanumeric ID number that you want to grab. The command line to download a new image is docker pull and then the name of the image you'd want to pull. And by default, you're going to be pulling from the Docker default registry that will then connect to your Docker daemon and download the images from that registry. The command line to run an image is docker run and then the image ID. And then we have the if we wanted to pull specifically from Docker Hub, then we would have docker pull and then the image name and colon its tag. To build an image from a Docker file, you would do docker build-t and then the image name and colon tag. To shut down the container, you would do docker stop container ID. The access for running a container is docker exec it container ID bash. So we've gone through all the different commands, but let's actually see how they would actually look, and we're going to go ahead and do a demo. So welcome to this demo where we're going to go ahead and put together all of the different commands that we have outlined in the presentation for Docker. First is just to list all of the Docker images that we have. So we do sudo docker images and we enter in our password. And this will now list out the images that we've created already, and we have 3 images there. So let's go ahead and pull a Docker image. So to do that, we'll go ahead and type sudo docker, and actually we don't want to do image, we want to select pull, and then the name of the image that we want to pull, which is going to be MySQL. And by default, this is actually going to go ahead and use the latest MySQL command, MySQL image that we have. So it's now going to head and pull this image. It's going to take a few minutes depending on your internet connection speed. It's kind of a large file that has to be downloaded, so we'll just wait for that to download. You can see the others have completed. Just waiting for this last file to download. Almost there. Once that's done, what we're going to go ahead and do is we'll actually run the Docker container and create the new container using the image that we just downloaded, but we have to wait for this to download first. Alright, so the image has been pulled from Docker Hub. And let's go ahead and create the new Docker container. So we're going to do sudo docker run -d -p 0.0.0.0 :80 :80, and then we'll put in MySQL latest, so we have the latest version, and we have our new token, and that shows our new Docker container has been created. Now let's go ahead and see if the container is running, and we'll do sudo docker ps to list all the running containers, and what we see is that the container is not listed there, which means it's probably not running. So let's go ahead and list out all of the images that we have within Docker so we can see whether it's actually listed there. So we'll do ps-a, and yes, there we are. We can see that we do have our new container, MySQL latest, and it was created 36 seconds ago, but it's in the exited mode. So what we have to do is we have to change that status so it's actually running. So let's change that to running state. We'll do sudo docker run dash it dash dash name, and we can name it SL SQL MySQL slash bin slash bash, and that's now going to be in the root, and we'll exit out of that. And now if we list out the Docker containers, we should see it is now an active container. Sudo docker start, and then we'll start the saying it, and we should now see it. There we are. It's now in the running state. Excellent. And we can see that it was updated 6 seconds ago. We're going to go ahead and we're going to clear the screen. Okay, now what we want to do is remove the Docker container. So what we're going to do is check list of images that we have. And so sudo docker images. Here are the images that we have, and we have MySQL is listed. And what we want to do is delete MySQL. And to do that, we're going to type in sudo docker rm-f image MySQL. Run that command, and what we'll find is the image. There's no such image. Oh, okay. So what we actually have to do is we have to go and see that the image is now gone. It's been removed. Excellent. It's exactly what we wanted to see. And we can also delete an image by its image ID as well. However, if an image is running and active, we have to kill that image first. So we're going to go ahead and we're going to select the image ID. We'll copy that, and it's going to, we paste that. It won't be able to actually run correctly because the image is active. So what we have to do now is stop the image, and then we can kill it. So it's in the running state. So we have to do, so we do sudo docker kill and kill SL, and that will kill the container. And now we'll see that the container has gone. And now we can delete the image. And that's going to be the image gone with the image ID. Ba-boom. Easy peasy. Okay, let's go ahead onto the next exercise, which is to, so here we are, we've listed all of the containers and they're all gone. So let's go on to the next exercise, the final exercise, which is to actually create a batch image. And we're going to do a batch HTTP image. So let's go ahead and write that out. So it's going to be docker run dash dit dash dash name white. That's going to be the name of this HTTP service dash p 8080:80 dash v open quotes $pwd close quotes colon slash usr slash local slash apache2 slash htdocs slash httpd semicolon 2.4. We'll run that. Put in our password again. So what we see is the port is already being used. So let's go ahead and see which ports. Let's go see if we can change the port or see what ports are running. So let's do sudo images and see which ports are being used, because it's either the port or the name hasn't been put in correctly. So sudo docker images ps sudo docker ps-a, and yep, there's port 80 there. So we'll clear the screen. So we're going to change the container name because I think we actually have the wrong container name here. So let's go in and change that, and we'll paste that in, and voila. There we go. Now working, and we'll just double check and make sure everything's working correctly. So to do that, we'll go into our web browser and we'll type in, as soon as Firefox opens up, type in localhost :8080, which was the port that we created. And there we are. It's a list of all the files which shows that the server is up and running. So let's have a look at what we have in our current environment. So today, when you actually have your standard machine, you have the infrastructure, you have the host operating system, and you have your applications. And then when you create a virtual environment, what you're actually doing is you're actually creating virtual machines, but those virtual machines actually are now sitting within a hypervisor solution that sits still on top of your host operating system and infrastructure. And with a Docker engine, what we're able to do is we're able to actually reduce significantly the different elements that you would normally have within a virtualized environment. So we're able to get rid of the bins and so we're able to get rid of the guest OS, and we're able to eliminate the hypervisor environment. And this is really important as we actually start working and creating environments that are consistent, because we want to be able to make it so that it's really easy and stable for the environment that you have within your dev and ops environment. Now, critical is getting rid of that hypervisor element. It's just a lot of overhead. So let's have a look at a container as an example. So here we actually have a couple of examples. On the right hand side, we have different containers. We have one container that's running Apache Tomcat with Java. A second container is running SQL Server in a Microsoft.NET environment. The third container is running Python with MySQL. These are all running just fine within the Docker engine and sitting on top of a host OS, which could be Linux. It really could be any host OS within a consistent infrastructure. And you're able to have a solution that can be shared easily amongst your teams. So let's have a look at an example that you'd have today if a company is doing a traditional Java application. So you have your developers working in JBoss on his system, and he's coding away, and he has to get that code over to a tester. Now, what will happen is that tester will then, typically in your traditional environment, then have to install JBoss on their machine and get everything running and hopefully set up identically to the developer. Chances are they probably won't have it exactly the same, but they'll try and get it as close as possible. And then at some point, you want to be able to test this within your production environment, so you send it over to a system administrator who would then also have to install JBoss on their environment as well. Yeah, this just seems to be a whole lot of duplication. So why go through the problem of installing JBoss 3 times? And this is where things get really interesting, because the challenge you have today is that it's very difficult to almost impossible to have identical environments if you're just installing software locally on devices. The developer's probably got a whole bunch of development software that could be conflicting with the JBoss environment. The tester has similar testing software, but probably doesn't have all the development software. And certainly the system administrator won't have all the tools that the developer and tester have, their own tools. And so what you want to be able to do is kind of get away from the challenge you have of having to do local installations on 3 different computers. And in addition, what you see is that this uses up a lot of effort, because when you're having to install software over and over again, you just keep repeating doing really basic foundational challenges. So this is where Docker comes in, and Docker is the tool that allows you to be able to share environments from one group to another group without having to install software locally on a device. You install all of the code into your Docker container and simply share the container. So in this presentation, we're going to go through a few things. We're going to cover what Docker actually is, and then we're going to dig into the actual architecture of Docker and kind of go through what Docker container is and how to create a Docker container. And then we'll go through the benefits of using Docker containers and then the commands, and finalize everything out with a brief demo. So what is Docker? So Docker is, as you'd expect, because all the software that we cover in this series is an open source solution, and it is a container solution that allows you to be able to containerize all of the necessary files and applications needed to run the solution that you're building. So you can share it from different people in your team, whether it's a developer, tester, or system administrator. And this allows you to have a consistent environment from one group to the next. So let's kind of dig into the architecture so you understand why Docker runs effectively. So the Docker architecture itself is built up of two key elements. There is the Docker client, and then there is a REST API connection to a Docker daemon, which actually hosts the entire environment. Within the Docker host and the Docker daemon, you have your different containers, and each one has a link to a Docker registry. The Docker client itself is a REST service, so as you'd expect, a REST API that sends command line to the Docker daemon through a terminal window or command line interface window. And we'll go through some of these demos later on so you can actually see how you can actually interact with Docker. The Docker daemon then checks the request against the Docker components and then performs the service that you're requesting. Now, the Docker image itself, all it really is a collection of instructions used to create a container. And again, this is consistent with all the DevOps tools that we have. The DevOps tools that we're looking to use throughout this series of videos are all environments that can be scripted. And this is really important because it allows you to be able to duplicate and scale the environments that you want to be able to build very quickly and effectively. The actual container itself has all of the applications and the dependencies of those applications in one package. You kind of think of it as a really effective and efficient zip file. It's a little bit more than that, but it's one file that actually has everything you need to be able to run all of your solutions. The actual Docker registry itself is an environment for being able to host and distribute different Docker images among your team. So say, for instance, you had a team of developers that were working on multiple different solutions. So say you have a team of developers and you have 50 developers and they're working on 5 different applications. You can actually have the applications themselves, the containers, shared in the Docker registry. So each of those teams at any time check out and have the latest container of that latest image of the code that you're working on. So let's dig into what actually is in a container. So the important part of a Docker container is that it has everything you need to be able to run the application. It's like a virtualized environment. It has all your frameworks and your libraries, and it allows the teams to be able to build out and run exactly the right environment that the developer intended. What's interesting though is the actual applications then will run in isolation, so they're not impacting other applications that's using dependencies on other libraries or files outside of the container. Because of the architecture, it really uses a lot less space, and because it's using less space, it's a much more lightweight architecture. So the files, the actual folder itself is much smaller. It's very secure, highly portable, and the boot up time is incredibly fast. So let's actually get into how you would actually create a Docker container. So the Docker container itself is actually built through command line, and it's built of a file and Docker image. So the actual Docker file is a text file that contains all the instructions that you would need to be able to create that Docker image. And then we'll actually then create all of the project code within inside of that image. Then the image becomes the item that you would share through the Docker registry. You would then use the command line, and we'll do this later on, select Docker run and then the name of the image to be able to easily and effectively run that image locally. And again, once you've created the Docker image, you can store that in the Docker registry, making it available to anybody within your network. So something to bear in mind is that Docker itself has its own registry called Docker Hub, and that is a public registry, so you can actually go out and see other Docker images that have been created and access those images. As your own company, you may want to have your own private repository, so you want to be able to go ahead and either do that locally through your own repository, or you can actually get a licensed version of Docker Hub where you can actually then share those files. Now, something that's also very interesting to know is that you can have multiple versions of a Docker image. So if you have a different version control, different release versions, and you want to be able to test and write code for those different release versions because you may have different setups, you can certainly do that within your Docker registry environment. Okay, so let's go ahead and we're going to create a Docker image using some of our basic Docker commands. And so there are essentially really, kind of just two commands that you're going to be looking for. One is the build command, and another one is to actually put it into your registry, which is a push command. So if you want to get an image from a Docker registry, then you want to use the pull command, and a pull command simply pulls the image from the registry, in this example using nginx as our registry, and we can actually then pull the image down to our test environment on our local machine. So we're actually running the container within our Docker application on a local machine. We're able to then have the image run exactly as it would in production. And then you can actually use the run command to actually use the Docker image on your local machine. So just a few interesting tidbits about the Docker container. Once the container is created, a new layer is formed on top of the Docker image layer. It's called the container layer. Each container has a separate read-write container layer, and any changes made in that Docker container is then reflected upon the particular container layer. And if you want to delete the container layer also gets deleted as well. So, why would using Docker and containers be of benefit to you? Well, some of the things that are useful is that containers have no external dependencies for the applications they run. Once you actually have the container running locally, it has everything it needs to be able to run the application. So there's no having to install additional pieces of software, such as the example we gave with JBoss at the beginning of the presentation. The containers are really lightweight, so it makes it very easy to share the containers amongst your teams, whether it's a developer, whether it's a tester, whether it's somebody on your operations environment. It's really easy to share those containers amongst your entire team. Different data volumes can be easily reused and shared among multiple containers. And again, this is another big benefit, and this is a reflection of the lightweight nature of your containers. The container itself also runs in isolation, which means that it is not impacted by any dependencies you may have on your own local environment. So it's a completely sandboxed environment. So some of the questions you might ask is, can you run multiple containers together without the need to start each one individually? And you know what? Yes, you can with Docker Compose. Docker Compose allows you to run multiple containers in a single service. And again, this is a reflection on the lightweight nature of containers within the Docker environment. So we're going to end our presentation by looking at some of the basic commands that you'd have within Docker. So we have here on the left-hand side, we have a Docker container and then the command for each item. We're actually going to go ahead and use some of these commands in the demo that we're going to do after this presentation. You'll see that in a moment. But just, some of the basic commands we have are committing the Docker image into the container. Kill is a standard kill command to terminate one or more of the running containers so they stop working. Then restart those containers. But certainly you can look at all of the commands here and try them out for yourself. So we're going to go ahead and start a demo of how to use the basic commands to run Docker. So to do this, we're going to open up terminal window or command line, depending whether you're running Linux, PC, or Mac. And we're going to go ahead, and the first thing we want to do is see what our Docker image lists are. So we can go sudo docker images, and this will give us, well, first we'll enter in our password. So let's go enter that in. And this will now give us a list of our Docker images. And here are the Docker images that have already been created in the system. And we can actually go ahead and actually see the processes that are actually running. So I'm going to go ahead and open up this window a little bit more, but this will show you the actual processes and the containers that we actually have. And so on the far left-hand side, you see under names, we have learn, Simplilearn, b_cool. These are all just different ones that we've been working on. So let's go ahead and create a Docker image. So we're going to do sudo docker run -d -p 0.0.0.0 : 80:80 Ubuntu, and this will allow us to go ahead and run an Ubuntu image, and this will run the latest image. And what we have here is a hash number, and this hash number is a unique name that defines the container that we've just created, and we can go ahead and we can check to make sure that the container actually is present. So we're going to do sudo docker.ps, and this actually shows on there. So it's not in a running state right now, but that doesn't mean that we don't have it. So let's list out all the containers that are both running and in the exit state. So let's do sucker ps-a, and this lists all the containers that I have running on my machine. And this shows all the ones that have been in the running state and in the exit state. And here we see one that we just created about a minute ago, and it's called learn. And these are all running Ubuntu. And this is the one that we had created just a few seconds ago. Let's open it up, and there we go. So let's change that to that new Docker container to a running state. So scroll down, and we're going to type sudo docker run -it -name my so this is going to be the new container name. It's going to be my Docker. So this is how we name our Docker environment, and we'll put in the image name, which is Ubuntu, and -bin -bash, and it's now in our root, and we'll exit out of that. So now we're going to go ahead and start the new my Docker container. So sudo docker start my, and we'll get the container image, which will be my Docker, return, and that started that Docker image. And let's go ahead and check against the other running Docker images to make sure it's running correctly. So sudo docker ps, and there we are. Underneath name on the right hand side, you actually see my Docker along with the other Docker images that we created. And it's been running for 13 seconds. Quite fast. So if we want to rename the container, let's use the command sudo docker rename. We can take another Docker image. Let's grab this one and we'll put it in rename, and we'll rename, and we'll put in the old container name, which is image, and then we'll put in the new container name, and let's call it purple. So now the container image that had previously been called image is now called purple. So we do sudo docker ps to list all of our Docker images, and if we scroll up, and there we go, purple. How easy is that to rename an image? And we can go ahead and use this command if we want to stop a container. So we're going to write sudo docker stop, and then we'll have to put in the container name, and we'll put in my Docker, the container that we originally created, and that image has now stopped. And let's go ahead and prove that. We're going to list out all the Docker images, and what you see is that it's not listed in the active images. It's not on the list on the far right hand side. But if we go ahead and we can list out all of the Docker images, so you actually see it's still there as an image, it's just not in an active state. It's what's known as in an exit state. So here we go. And there's my Docker. It's in an exited state. So that happened 27 seconds ago. So if we want to remove a container, we can use the following command. So sudo docker rm for remove my Docker, and that will remove it from the exited state. And we're going to go ahead and we're going to double check that. And yep. Yep. It's not listed there under exit state anymore. It's gone. And there we go. That's where it used to be. All right, let's go back. So if we want to exit a container in the running state, so we do sudo kill and then the name of the container. I think one of them is called yellow. Let's just check and see if that's going to kill it. Oops, no, I guess we don't have one called yellow. So let's find out the name of a container that we actually have. So sudo docker kill. Oh, we're going to list out the ones that are running. Oh, okay, there we go. Yellow isn't in that list, so let's take Simplilearn. And so we can actually go ahead and let's write sudo docker kill Simplilearn. And that will actually kill an active Docker container. Boom, there we go. And we list out all the active containers. You can actually see now that the Simplilearn container is not active anymore. And these are all the basic commands for Docker container. So let's dig into what a Docker swarm is. So a Docker swarm is essentially a tool that allows you to very easily create and schedule multiple Docker nodes. So really 2 or more Docker nodes. And you can have quite a large number of Docker nodes in a single swarm. Each node itself is actually a Docker daemon, and that daemon is able to then interact with the Docker API and have all the benefits of being a full Docker environment. One of the other advantages you have is that each Docker container within the swarm can then be deployed and managed as a node in that entire clustered environment. So what we have here is a breakdown of the 5 key elements within a Docker environment. You have the Docker container, you have the daemon, the Docker images, and the Docker client and Docker registry. So the Docker daemon itself is what does all the work interacting with the actual host operating system to be able to manage the Docker containers. So if we look here we have set up an environment where we have 3 Docker containers being run with Docker. And what we want to be able to do is be able to interact with the environment, because what would happen if we actually have something change in our environment? So we have the environment set up as a Docker swarm and one of our containers fails. What we're able to do is use the swarm to be able to correct that failure. So the Docker Swarm Manager is able to come in and reschedule containers. And as you would imagine, the actual Swarm node has full backups and full redundancy for any kind of failures that would happen. And we would do all of this work through command line interface. So let's go through some of the features that you have within the actual Docker Swarm itself. So a key feature for Docker Swarm is that it is fully decentralized, which means that it makes it very easy for teams to be able to access and manage the environment. As you would expect as well, is that the communication that happens between the manager and client nodes within the swarm is highly secure. And of course, this is really just a fundamental that you should have for any kind of solution, but it is good to know that Docker Swarm has that built in. There is also auto load balancing within your environment, and you can actually script that into how you write out and structure your swarm environment. And that load balancing then also allows you to then convert that swarm environment into a highly scalable infrastructure. And then rollback task allows you to be able to roll back environments to previous safe environments. So if, say, something does get pushed out and something breaks, you're able to immediately roll back into a safe environment. So each of the containers are pushed out and are controlled using services, and they actually happen to be REST services, which make it very easy for you to be able to integrate within your environment. And each of the different services contains a group of containers of the same image. Now, by having this structure, it allows you to be able to scale your application appropriate to the demands on your service. So if you have a service that needs to have a significantly larger number of services for it to run, you can actually scale that appropriately, and that can be either geo or demand based. One of the requirements for setting up a Docker Swarm is you must have at least one node deployed. So the way that the architecture is set up is that you have a manager node and a client node, and there must be one of each for the entire environment to be able to work effectively. So, here we are just jumping ahead of ourselves a little bit. We have two types of nodes in a Docker Swarm. We have the manager node and we have the worker node, which is the client that does the actual execution of the tasks. The manager node, very similar to other systems that we've talked about on Simplilearn, allows you to actually control and manage the actual tasks that are being executed by the worker nodes. And the worker nodes, as you can imagine, then actually execute the instructions that the manager are sending out to it. So here we have a situation where we can illustrate what would happen with a manager node sending out commands to different worker nodes. The manager is fully aware of the status of the entire swarm environment at all times. This is because of the two-way secure communication that's going from the manager to the worker environment. The workers, as you'd expect, are accepting tasks that are being sent from the manager. So if the manager sends out a task saying that you need to be running as a MySQL environment, then the worker node will then convert to a MySQL environment. And all of these environments are scripted and controlled by you as the manager. The actual worker nodes themselves actually have a client agent, and that client will then communicate all different states of the infrastructure back to the manager, so that any time the manager node is in full control of the entire swarm. The manager is the controller of this environment, and so you always want to be able to ensure that the manager has full access to all of the work that's happening within the swarm, and this allows you as the manager to be able to control your swarm and very quickly be able to react to any changes without having to rely on manual installations of software and hardware. And as we covered earlier on, there is a REST API that uses the communication over HTTP from the manager to the worker node. It's interesting to note that it is a REST API because if you wanted to, you could actually integrate that API into custom applications and even then create automated Docker images to be created on demand from third-party solutions that you may want to create. So one of the things that's a big advantage with having a swarm is that once you've actually created the swarm, any of the services that you create can be accessed by any node of the same cluster. One of the things you do have to do, though, is you have to specify what container image that you're going to use when you're creating a new service. And you can do that either through a centralized Docker Hub environment or through your own private Docker Hub environment. One of the things that's interesting is that you can set up commands and services to be either global or replicated. A global service will allow you to run a service consistently on every node within the swarm, whereas a replicated service will only push out functionality and tasks to specific worker nodes within a swarm. So you may be asking yourself, hey, isn't a service and task the same thing? No, they're kind of not in the Docker world, and the difference is a service is a description of a task or the state, whereas the actual task is the work that needs to get done, and that's the differentiator here. So what you can do as a Docker user is you actually create services, and then you can then define when you want them to start as tasks. Now, what's interesting is that when you do assign a task to a node, that same task cannot be assigned to another node. Also, what's interesting is that you can actually have multiple managers within a Docker Swarm environment. If you do, however, go down this path, you have to elect one manager to be the primary manager and the other managers to be secondary managers. In many ways, those secondary managers are really similar in concept to worker nodes in which they have the capability of a manager, but they are dependent on that single primary manager to be able to provide the right instructions and for services and tasks to the entire Swarm environment. So if we kind of recap some of these, we have a command line interface, which allows us to create and connect via APIs. And that those APIs that we connect to in our Swarm environment allows us to do orchestration via tasks and services. The task allocation allows us to allocate work to tasks via their IP address, which allows them to execute them on the work. And then the worker nodes themselves have to connect to the manager node to be able to check for when tasks come in so that they are keeping a consistent communication back and forth across the entire swarm. And then the final stage is to actually execute the tasks that have been assigned from the manager node to the worker node so that you have a successful execution of the solution you're looking to build. All right, so with that said, let's go ahead and we're going to do a demo. So we're going to go ahead and do a demo and showing how you can run Docker Swarm. For this, you'll need to have both a virtual environment running your manager and your working environment. So here we have our worker and here we have our manager. So we're just going to open up terminal window and we're going to go into the manager for terminal window. So the following command here is used to initialize Docker Swarm. We're just going to type this in. So sudo docker swarm init, and we put the IP address for the network we're connecting to. And we'll put in our password. And here we have now connected. And this is our manager node, and what we want to be able to highlight is the specific token which identifies the Docker Swarm environment. And this is our token right here. So we're going to copy that because we'll need to use that for our worker environment. So here we are in the worker environment, and we'll use the token that we just copied as a way to be able to connect to the manager and connect to the Docker Swarm environment. And so sudo, we'll paste in the Docker Swarm and we'll join that. And now here we shows that we have joined the Swarm environment as a worker. And now that we're in the manager, we can actually show that we actually have that worker in the environment. So there's Docker node ls to list out all of the items in that environment. Sorry, we actually did that in the wrong area. So we're on the right, sudo docker node ls to list out all the nodes in the swarm. And there you are. You see we've actually connected the worker to the manager node, and both are active, and the manager is the leader and the worker VirtualBox is in the swarm. Okay, we're going to go ahead and create a new service. So Docker Swarm create, and we're going to just change the name to Hello World for the new service, and we're going to use the Alpine image from docker.com. Takes just a moment for it to run. There we go. And there we go. Services converged. So what we have now is a new service that has been created. Let's go ahead and we'll list out the services. And here we have our new Hello World service. And we go ahead and check the Docker containers, and we're going to do Docker PS, and here's our Alpine. It's running the latest image, and that's the Docker container ID. And we can see that it was just updated. And so what we're going to do is use the same command in the worker node and make sure everything is working over there. So go over to our worker, paste that in. So what we see here is there is no image or container created because it's not in the worker node, it would be in the manager node. So we can go ahead and create the new service. And we're going to make the mode global, and that way the service is available across all of the swarm. So we're just going to execute that work. Takes a moment. And there we are. Done. Work has been completed. And we have the two different IDs, which shows the two different services running. And if we go back to the worker mode and we run sudo docker ps again, and there we are. Now we see that we have the Hello World new virtual environment has been added with the image of Alpine, and we also have the new token ID for that. If we want to kill a node from the swarm, we can use the following command, which is sudo docker swarm leave -- force, and that will force the node to leave the swarm. So one of the questions that will come up though is, what if you want to use two containers in a single service? And an example of this might be like a web server that is using a database, but the database may be in one container and the web server may be in another container, which is very typical for your own web and database infrastructure. So very similar scenario, but how would you do this with Docker? So by using just Docker itself, it's actually very difficult to do this. You can do it, but it's just very time consuming and just not a very good use of your productivity. But with Docker Compose, you can actually do the whole process quite quickly and easily, and hence the reason why we have Docker Compose, to allow you to have two or more Docker containers running in the same environment, being able to communicate as if they were running in a production environment. So let's dig into what Docker Compose is. So let's consider a scenario that you'd have today. So Myntra is a fashion website similar to Amazon, and you would go to Myntra with your web browser, and on that website you would go through a number of activities such as logging into your account, browsing a catalog, you'd have your checkout application server, and you go through the typical process of building out an application. Behind each of these services are different products, such as you'd have an account database, you'd have a product database, different checkout processes, and these would all be run behind the scenes. And each of these can be considered a microservice. So the more microservices you build into your environment, the more complexity you're adding, and the more of value it would be to have each of these services in their own container. But as a developer, you want to be able to jump from one container to another container, so your login account can then be passed on to your product catalog and then be able to move through the whole process. So the environment that you would see today would be more like what we're showing right now, where you'd have your server and your database, and you may have a server running on Apache Tomcat or SQL Server. You'd have different databases, and you'd want to be able to have each of those in their own containerized environment. So the way that Docker Compose runs is that it works as a single service. So you have the Docker Compose running multiple containers, but the perception is of a single service run. The thing that's great though is that each of those containers will run in isolation, but they can interact with each other. So unlike a normal Docker environment where you have multiple Docker images running completely in isolation of each other, these are images that will run in isolation but can interact with each other. The Docker Compose files are very easy to write. They're all written with a scripting language called YAML, and YAML is an XML-based language. It actually stands for yet another markup language, but it's an XML-based language and it's very easy to use. The great thing about learning YAML is that a lot of open source tools in the DevOps environment use YAML as the scripting language. And then finally, in Docker Compose, as a user, you can actually go in and trigger all your services within the containers to start with a single command. As you can imagine, this dramatically reduces the amount of work that you as a developer have to do. So let's take an example of if you're running a container, one with a Nginx server and one with a Redis database. You can create a YAML Docker Compose file that actually has the instructions on the containers needed to build out both environments. And then you can run each of those environments separately, but have them connected as a single service. So the benefits of Docker Compose is that you have a single host deployment environment. You can run this all on one piece of hardware. You can have a quick and easy configuration using YAML scripts. The productivity that you get as a developer significantly increases because you're not having to have time wasted trying to configure just traditional Docker containers by themselves. You now have a way of being able to interact with those containers. And then finally, security is at the center of all of these containers. So each of those containers are completely isolated from each other, and they are controlled with the same level of security that you'd have with a traditional Docker image. But there is a question here around Docker Compose. Isn't it similar in concept to Docker Swarm? Because at a high level, it kind of seems like both do the same thing. And the answer is, well, actually, no, they're different. There are similarities, but there are also differences. And particularly for a developer, these differences will really start coming out in scale as you start working on your solutions. So let's look at Docker Compose. So Docker Compose will allow you to create multiple containers on a single host. And that's the important part, having a single host, which is maybe your development PC. With Docker Swarm, it also allows you to create multiple containers. However, you have to manage those multiple containers on multiple hosts, which makes a lot of sense if you're running an operations environment, but not so much if you're doing a development environment. And Docker Compose is scripted with YAML, which is very easy for you to be able to control your scripts. Docker Swarm doesn't have a scripting technology like YAML, so it's a little bit harder to work with. So what we have here is just some basic commands that allow you to get up and started working with Docker Compose. In our next demo, we're actually going to take you through how to use all of those commands. So we're going to go ahead and do a demo on how to use Docker Compose. The first thing you want to do is check that you have Docker installed. So what we're going to do is we're going to open up the command window and we're going to type in Docker. You'll be able to see now that we have Docker installed. If you don't have Docker installed, go ahead and install Docker. You can go to Google search to install Docker and they'll give you the instructions for that. We also have videos that we've already done. If once you have Docker installed, then you want to do a Google search on Docker Compose or go to the docker.com website and select for the Compose section and look for the install Docker Compose instructions. So we already have another tab which has the instructions already installed. You'll see on the left hand side there are a number of Docker tools. You want to expand the Docker Compose section, select install Compose, and then on the right hand side you'll have different install options for Mac, Windows and Linux. If you're installing on those platforms, make sure that you're copying the correct command lines. There's a couple of command lines you want to copy. Copy the first one over and we paste that in, and it's going to go ahead and download all of the files for Compose. It takes a while, but we have to get another file, so while it's downloading we'll go get the other command line. Just go back and grab it real quick. It was a little fast there, but we'll copy that over. There was a second command instruction and post that command. Yep, there's the command right there. And that will apply the appropriate binary. And once you've done that, you can actually go ahead and validate that you have the correct version of Docker Compose installed. And for that, you want to write the command docker-compose space -- version. And that will then give you a version build. Once you know that you have a version build, that means that you have everything installed correctly on your machine. So you can see here that we have a version number, which means we have everything installed. You might see a different version number depending on how old the video is when you're watching it, but we're using very content at the moment. And just go ahead and clear the screen. And now what we're going to do is create a folder where we're actually going to install the YAML file that will have the instructions for our Docker Compose environment. So we're moving the cursor to the desktop, and on the desktop we're going to create a new folder and using the mkdir command, and we'll call this one Docker Compose F for file. And then we'll move the cursor into that new folder by using cd command. And now we are in the folder called Docker Compose F. And you can go look at your desktop and you'll see it's there. And now you want to select #touch docker-compose.yml, and that will actually create the new YAML file for you. And you can use the ls list command, ls docker-compose.yaml, and that'll allow you actually now to step in and edit that file. So let's go ahead and hit return, and that'll allow us to go in and edit the file. So now I'm in the editor and I'm going to write some instructions. So I'm going to put a couple of mistakes in these instructions so we can see how Docker Compose catches those mistakes. But most of this is going to be fairly correct, so you can just type this out. So we're going to start with services : then we'll do web : and then we'll create image colon, and we'll do Nginx, and then we'll do a database colon, and we'll call the image Redis. And so what you can see, because we have two reference images, we're actually calling two different images, two different containers that will be created by Docker Hub. So what we're going to do is where we can actually show you how that's pulling in. You can go to Docker Hub and you can actually see the references to the images that we've just created. So go to Docker Hub, which is hub.docker.com, and you'll see that Nginx, Redis, those are the default names for the images. So you could do other images like HTTP for Apache web server if you wanted to. There are a lot of images in Docker Hub, so certainly have a lot of fun building tools from that environment. So we're going to save those files in the Docker image, and we're just going to do :WQ to exit this screen. Save the text. Let's go and run our YAML file, and you'll see the two different error messages that will come up. So we're going to do cat docker-compose.yml, and here we have a display of the text that we just wrote. And now let's go check the validity of the file that we just created. So we'll do docker-compose config, and we should get an error message. And there we are, error message. And the reason why we have an error message is because the spacing is not correct in the YAML file itself. So let's go to the actual YAML file that we created. Let's go through, and we're going to use just the file finder, and you'll actually open up the YAML file in your text editor, your favorite text editor. And here we have the code that created it. And let's use the correct spacing so that everything is spaced out appropriately in the image. And so this is the spacing that you'd expect to see, a space, a line between surfaces and the first image, and the first image is a tab in, and then it references what the image is. And let's go ahead and clear the screen, and we'll see whether or not we've got that all correct. Let's clear the screen, and we're going to check that everything is running correctly. And we're still getting an error message. And the reason why we're getting another error is that there's still a config error in the actual YAML file. So one of the things you have to do when you're creating a YAML file for Docker Compose is you actually have to have the appropriate version number in there. So what we have to do is we have to go and find which is the appropriate version. And there are three major versions, 1, 2, and 3, depending on the age of Docker that you have installed on your computer. So if you have the very latest version of Docker, 18 and newer, you would put 3.7 as the version number. And what we're going to do is we're going to just check on the version that we have installed. And so we'll just clear the screen, and then we'll just do Docker version. And what we have is our version of Docker is 17.12. Now this is the version of Docker, not Docker Compose. It's your main Docker environment. And so if we go back to our web browser, we'll actually see that version 17 should align with version number 3.5. Yep, there we are, version 3.5. So what we want to do is go back into our YAML file, and the very first line that we want to put in above the services is the version number. And that version number we're going to put in is 3.5. So we type in version, and we put colon, and then version number is in quotes, and you save that. And now what we can actually do is we can actually go ahead and use the single line instruction to run both of these two images that we've created, because everything is configured correctly. But with just one note, you'll see that the version number is actually at the bottom of the list, and that's just the way that Docker Compose works. It pulls out the services and the images that you'd create, and then puts the version number at the bottom of the list. So in the presentation, we talked about how you can use one line to trigger two or more images. And so to do that, we're going to do sudo docker-compose up-d. And it's going to create the two environments. We have the web environment and the database environment. And let's use sudo docker ps to actually list out all the processes that are running right now. And there we are. We actually see all of the images are running. We have the names, the commands, the images, and everything's up and running. And if we want to close both of those images, we can actually use a single line of command as well. And that command will be sudo docker-compose down. And that closes both of the images. And we can see that all the databases and the web services images have been closed, and sudo docker ps will actually list that there is nothing running. And that's how to use Docker Compose.
So if you are looking to become a Docker expert, consider the postgraduate program in DevOps by Simplilearn to gain expertise in Docker. This program offers blended learning that combines live online DevOps certification classes with interactive labs that will give you hands-on experience. You will gain expertise in the tools like Terraform, Maven, Ansible, Jenkins, Docker, JUnit, Git, and more. We prefer 1 year of prior experience to enroll in this course. So why wait? Enroll the course from the link in the description box.
So we are going to talk about what is a Docker, what is a Docker file, what is the syntax of Docker file, and how to build a custom Docker image with the help of Docker file. And in the end, we are going to see a particular demo related to the Docker files over here. Now let's talk about what is a Docker. Now Docker is a configuration management tool which we are pretty much using to prepare the automation of the deployment of the software, of the applications. Now in this case we make use of the Docker containers using which we can host our applications, and within these Docker containers we are typically hosting both the application source code and the dependencies all together. So both the things are getting packaged all together into a single unit called Docker containers and getting hosted onto the server. These containers are very efficient in work because they are not taking that much utilization and resources, and at the same time they can be shared across different environments also. So the same container can be easily deployed across different environments as such. Now it helps us to maintain the isolated application. It helps in having a high productivity there, and it also helps us to resolve all the problems which is related to the dependencies for your software, because we are packaging up both the source code and the dependencies all together in the single unit, in the single entity, and that's where you will be able to get a particular final solution called as a Docker container over here. So Docker container is a complete package using which you can have like both the applications and the dependencies bundle up together into a single entity, and that's where we call it as a Docker container. Now what exactly is an Docker that let's see a particular difference between the virtual machine and the Docker here. Now if you see on the left hand side we have the host operating system which is available there. Let's say I have a laptop. In this one we have a Windows 10. Now we have a hypervisor on top of that. Now hypervisor is a software which is used to manage the virtual machines. It's a software which is available there which takes up all the requests from the virtual machines, process it, and then give the response back. So hypervisor acts like a medium between the virtual machine and the host operating system resources. So it's going to give that a particular virtual environment to the virtual machines. And then we have a virtual machines where in fact a guest operating system is there, then application binaries, then the application is hosted. So this guest operating system actually takes up a lot of utilization, and this was the old mechanism where we used to follow this mechanism for hosting our applications. So all the applications are pretty much getting deployed in the same manner on the form of the virtual machines here, right? Now if you talk about the new method which we are talking about right now is in Docker. So here we have host operating system, but instead of hypervisor we have now the Docker engine which is available there. Now this Docker engine is something which is making sure working in the same way that how the hypervisor is behaving, but it's much lighter as compared to the hypervisor. So Docker is very lightweight as compared to the hypervisor here. And here we don't have the concept of the heavy duty guest operating system over here. So the guest operating systems which we are using in case of Docker containers are very small in size. The size of guest operating systems is in GBs in case of virtual machine, but in case of Docker containers it's pretty much available in the MB size which is there. So the size of the guest operating system in case of the virtual machine is very small as compared to the virtual machine, and that's the biggest benefit, because again it will help the containers to have a low utilization, low consumptions, and that improves the overall performance of the overall mechanisms, and how exactly the new method of application deployment really helps us to go for a particular advanced mechanism. So that brings on a very good and the efficient way of doing the deployment of the applications. Now let's talk about what exactly is in Dockerfile here. Now, Dockerfile is a concept which is being used as a build script. So it's being used so that we can have a build script there. So this will definitely helps to see that how we can go for a build of a Docker image, a custom Docker image. Now, when we are using the Dockerfile concept, so it really helps to prepare a kind of Docker image. So doc image is the end result when you are going for the mechanism, when you're going for the Dockerfile build up here. So Dockerfile is a build script which is available for preparing the custom Docker containers, because not every Docker image is available on Docker Hub. So some containers you have to use, some images you have to use to work on that part. Now Dockerfile is a very simple straightforward text file which is available there, and it's basically used to build up custom Docker images. So Dockerfile is basically used to prepare so when you're running the Docker build, so it's actually going to build up a particular custom Docker image, and that will be given to you. So Docker image is the whole build process which is being done. So it's a custom process which is available and being done over here in this case. So you got a Docker file, you run the Docker build command, and that's how you will be able to get a Docker image. So whatever the steps you are having in the Docker file, that will be processed one by one, and as a end result, you will be able to get a full-fledged Docker image over here in this case. Right, now let's talk about the syntax of the Docker file. So Docker file is equal to commands and the arguments. So whatever the things you want to put up, so in the Docker file you can do that, and as a part of the execution, so you will be able to get a particular end result. Now it's a kind of a mechanism where we feel that how the execution and the modifications can be done. So the comments which we are trying to do over here is that, you know, we can put up the whatever the comments we want to put in the case of Docker files, we can do that. Comments is a standard process in preparing any particular file or any kind of code, because it helps us to understand that for what reason we are preparing that particular line. Then we have the particular run statements. The commands are there, so you can see that we are running a particular command called echo. So using the run attribute, we are basically going ahead and running a particular command into our system as part of our Docker file over here. Now, how to build up the Docker images using the Docker file? So you know, Docker file is just a template which is available there, where we are putting up that what are the different steps we want to follow, and these steps, when we follow one by one, step by step, so that's where we will be able to get a particular final Docker container over here. So Docker image is getting converted as a Docker container, and we are getting a Docker container as an end result. Now Docker file is being built up and stored in the version control system, and this particular Docker files, when we are processing, so it prepares a respective specific image layer over here, and this image layer is something which is benefiting us, that how the executions can be done and how we can manage on that part. So that really helps us to see that how the executions and the things can be managed, and that can help us to see that how the management of the things can be performed as such. So Dockerfile is a very good concept which is there, using which you can prepare any kind of custom Docker image, and it can be very easily handled also, and it's a fully automated mechanism. You can use it inside the CI/CD pipelines for automating the Docker images. Right, now it's Docker image is a layer by layer mechanism which is there, in which we have multiple layers. Each and every layer we are doing some specific entry, some specific task, or some, you know, changes we are trying to deploy in part of these layers. Right, so you can use the particular Docker build command to perform the executions, and you will be able to get a particular response, and output will be given back to you. So Docker file is basically helping you to see that how the executions can be done, and you will be able to get an end result over here. So the Docker image is the final result which we are getting when we are talking about the Docker file here. Right, so these are all read-only formats which is available. You cannot modify these directly, but yes, with the help of Docker file, you can do whatever the changes you want to deploy on these Docker images. right? So this is a small example where we are using a base image as an Ubuntu 18.04. So we are using the from attribute to specify that yes, we are going to use the Ubuntu 18.04 here. Then we are pulling the file into the directory. We are transferring a particular file inside the Docker container, and then we are running a make command, and then cmd attribute is there, using which we can run the command on the runtime on the Docker container. So these are a very basic example, but eventually when we are done with this Docker image, we will be able to get a 4-layered Docker image over here, because there are 4 steps, and then hence it will be providing you a particular 4 layers in your final Docker image over here. So layer by layer these changes will be done during the build process, and in fact using the Docker history command you can see the layers, these layers information also, right? So layer 1 is Ubuntu 18.04, layer 2 is pull, and the third layer is there where we can run the make command to run this file which we have pulled on, and then finally the last one is there where we are running like using the cmd command. So the difference between run and cmd is that cmd will run only when you run a Docker container. So run attribute will be executed during the Docker build part. So this is pretty much is a way that how we can go for the execution of a Docker file, and how we can go for the build up of a custom Docker image over here. So these are the some couple of attributes which we are using in the Docker file here. Right, now let's talk about the entry point over here. Now entry point allows you to specify a command along with the parameters, right? So let's say that you want to run a particular command over here in the Docker container. So entry point is something which you can use to refer to that. So application is the command which you're trying to run, and then you can give some arguments to that, and argument 1 is what you're trying to run over here. So entry point is very important because that eventually helps to see that how the executions can be done, and the implementations will be done over here in this case, right? So you can see like you can run a command called echo, and then you can use the parameters also. It's not like only the commands can be used, but you can in fact use the arguments also. Now add is an attribute which is available in the Docker file, which is primarily used to transfer the files from the host machine inside the Docker image. Now let's see that you are trying to prepare your own custom Docker image. Apart from the dependencies, you need the source code also, right? So the source code needs to be transferred inside the Docker image, and for that reason we can use the add attribute. So add attribute requires a source and destination. Source will always be the path on which on the host machine the files are present, so we can give that. And destination is the folder which is available inside the particular Docker container where we want to store the files. So you can use the example over here just like this. You can use, and you can give 2 entries. One is the source, one is the destination. And once that is done, so you will be able to see your files being stored up in the destination directory once the final Docker image is prepared. Then we have env attribute. Now env is something which is used to set up some environment variables, which is required of course for the Docker image, for the application which is running inside the Docker image. Now environment variables are something which you can hardcode during the Docker build one, but using the when you are running, like when you're creating the Docker container, at that time also you can override these environment variables. So environment variables are very important because first during the build process you can hardcode some values, but if you really want to change them during the runtime, that also is being supported by the environment variables. So most of the times we use it as a kind of a key value pair, just like in Linux we use to set up a particular environment variable. So the key value pair is being used in case of env attribute. Maintainer is there where we can describe that what is the details about the author. These are the fields which is available in the top, so where we can give the author name and the author details like email ID and all, so that we know that who is the person who is maintaining this particular file, and we can reach out to them in case any issues are there for the Docker files here, right? So that is what we have here in this one. So now we are going to see that how we can go for a small demo on Docker file, and we can go for the implementation of this particular Docker file and prepare a custom Docker image. So let's just wait on that part. So let's see some demo over here. Now in this one we have got two examples. One is the Python, one is the Node.js one. So first of all, what we need to do is that we need to process the Python one here. So this is the sample Docker file which we have got here for the Python. Now all this one requires a Python file which is already present on the server, and we are going to transfer, we are going to copy this content over here. This is the specific Docker file content which is available to us, and all we need to do is that we need to put this content across the server so that we will be able to build our custom Docker image. So let's go back to the server. So here we have already got the Python file which is present. So we have to create a Docker file here which will have the steps related to the Docker image preparation over here. So we will be including some steps over here, that these are the different steps we want to configure, we want to set up over here in this one. So Python 3.6.4 is the version of the Python which we want to configure, and then we are going to transfer some files into /app. We are also setting up the working directory as /app, and ultimately we are running a command called pip install flask to do the installation of Flask package, and then we are starting the specific applications on that part. So I'm going to save this file, and once I save this file, so all we need to do is that we need to create a custom Docker image, right? So right now there is no image which is available over here, and it's in complete empty instance. So I'm going to run a command called docker build -t python -am dot. So docker build is the typical command, but -t is for the tag, that what kind of Docker image you want to build, and then we are giving a image name, and then we are specifying dot over there. Now once we are done with that, so it will pick up all the things one by one. The basic Docker image is being pulled down, then some sequence of steps is being executed. So it's a step-by-step process which is happening over here in this case, and we are then transferring some files in the /app, and then ultimately we are going for the pip install flask. So it's installing those packages, and at the end the final Docker image will be prepared and will be given back to us. So we will be able to get this Docker images over here. When we run that command, we will be able to find out that we got our custom Docker image also available. And as you can see that the basic Docker image is also available in this one, but yes, we have added up like around 10 MB of work we have added on top of this Python based Docker image here. So that's how we are able to do the processing over here in this case, in this setup. So that's what we can do to prepare a custom environment of Python with the help of the Docker file here. Now let's see that we will be proceeding on with the Node.js to see that if the Node.js kind of setup also can be done. Now for Node.js, again, of course, we got the specific Docker file which is present, so we can process that. But let's create a new folder over there. So I'm going to create for a new Node.js folder so that we can create the work all together in this one. So I'm going to run a command called npm init, which is the command to initialize any empty project in case of Node. Now you can typically bring down some real code also, or you can say that I want to process an empty project. So you can give the configurations, you can give the custom names, but I want to process with these default name itself. So ultimately it's going to create an entries like you will be able to see like all these values which we are not providing. These standards value will be picked up for the specific code, and at the end you will be able to get a package.json file created over here in this one. Now you can actually bring down the steps that how you can perform, or you can build up a custom Node.js based Docker image. Now these Docker files is giving you the capability that you can convert a full-fledged application which is deployable on the virtual machine. You can actually convert them in the format of the Docker containers over here in this one. So that's what we are going to get over here with this particular setup or these mechanisms. So let's go back to the document and see that what exactly we can copy the Docker file. So we have got this Docker file over here. So all we can do is that we can copy this one. So once we copy this specific file here, so all we can do is that we can transfer these files into the onto the server. We can convert it into the Docker file there, so that we will be able to set up the configurations and we can perform the setup around that. So Docker file is again we want to create and we want to set up on that here. So let's go back to the server. So here we want to create a Docker file, and we want to set up the files inside that. These are the different files which is being available, which is being configured over here in this one. So we are running like node server.js, which is the master file. So we are doing an expose of 8080. Then of course we have copy commands which is there, then npm install command is there, and then package.json file is also there. Now what you need to really do is that you need to go for a server.js file which is available, in which you can configure that how the setup needs to be done and how the configurations should be performed there, because that's a command, that's a script which is going to be executed within the container. So let's copy the content. Now I'm going to copy this content over here, which is like a sample node.js code which is available. So I'm just copy this one and transfer it to the server. So server.js file we have to create here, just like we did in case of the Python, because this is the source we want to transfer inside the Docker container. So this is what we have got. Now I'm going to transfer like I want to change this port value from 5000 to 8080 because that's what it's configured in the Docker file. Of course you can configure 5000 also, depending on your requirement you can do that configurations. Now you have got these two files over here in this one. So all you need to do is that you need to run like docker build -t node.js -app and dot. So it will automatically pick up like what exactly it will go for the node.js basic Docker image over here. So that will be processed over here in this one. So step by step it will be able to do the configurations. So first of all it will download the basic Docker image, which is quite more in size over here in this one. Once it's downloaded onto your system, then it will proceed further with the build activity on processing the Docker file, performing the execution. So all that stuff will be performed with this help of this Docker build process over here. So it's going to process it one by one in this one, and it's going to the next step where it's transferring some of the files, like creating some working directory, transferring the files, putting up there and running the npm install command, and then ultimately it will expose the port, and then it will have the cmd attribute configured over there. So this is basically typically trying to portray that how a particular Docker image can be built up. And of course once the build is success, you can validate it with the help of Docker images here. So this is the app Docker image which is being prepared of 911 MB, and we have got it like a final package where the runtime is also there and the code base is also available. Now you can pretty much experience it like with other actual source codes, like you can download some pre-configured Node.js websites or the source codes there, and you can try to run them onto the Docker container so that you can get the full the complete idea about that how it goes on. But right now these are the basic Docker image which you can prepare and you can build up over here in this one. So that's how it really works on for you. Now let's see that what are the different commands we have for the Docker here. Now the very first one is that what are the different images related commands which is available there. The very first one is the command which we typically use to prepare a custom Docker image. Now I can easily go to the Docker Hub and I can pull down a Docker image which is available there. But let's assume that you are working on application source code. So you want to prepare a Docker container for that. Now that Docker container, you will not be able to have it on the Docker Hub. You have to prepare on your own, right? So in order to prepare your own Docker image, all you have to do is that you have to run docker build command. Now in this case, we have to prepare a Docker file which will act like a kind of a Docker build script. Just like in case of Maven, we have pound.xml file, and in case of and we have build.xml file. So here we have the Docker file which is available there, and this Docker file makes sure that whatever the steps are mentioned in this Docker file in the build script, it's going to perform a series of steps and the build will be done. So docker build is the command. -t is the tag that what exactly name whatever the image you are building. So what exactly tag name you're trying to provide over here. So here we are using a tag name called my image, and then after the colon we are providing that what version we want to go here, 1.0, 2.0, 5.0. so whatever the version you feel that you want to refer, you can do that. Now this is the exact way that how in the actual world the Docker images are getting built up by the respective vendors. Let's say that Jenkins wants to prepare a Docker image. So they will be preparing the Docker file in the same manner and prepare these Docker images and publish it to the Docker Hub. So all the Docker images are built up, the custom Docker images are built up with the help of Docker file. So docker build is the command which will process the Docker file and give you a particular Docker image in the end. Now, how to list down all the Docker images? So docker list ls is something which is there. So this will eventually help you to list down all the Docker images which is listed on or which is available into your system. So that will be listed out over there for you. If you feel that you want to remove a particular image, in that case you can go for docker image rm command, and whatever the image you want to remove, you can give the respective image name and the tag name there. So docker image rm command is there, using which you can actually see that how the image can be deleted from the host over here in this one, right? So whatever the ways, whatever the mechanism is there, so we are making sure that how the image can be built up and how we can go for the built up and a particular image can be deployed over here in this case. So in order to delete a docker image, so you can go for docker image rm command to remove a docker image completely from the docker host. So these are some couple of commands which is available there, using which you can actually interact or manage the Docker image. Because in order to prepare or in order to run a Docker container, we require a source, and that source we are going to get it from the Docker image.
So now we are going to see that how we can execute these commands. So first of all, what we need to do is that we need to see that how Docker build works. For that, we require a Docker file. So I'm going to have a simple Docker file over here, in which we are going to have a basic Docker image selected as an Ubuntu. After that, we are going to go for the run attribute, where we are going to do the installation of a specific package, like let's say Git. And accordingly, you can, whatever software you want to prepare, you want to set up, you can do that and put up the commands over here in this Docker file. So I'm going to save this file, and after that what I need to do is that I need to run like Docker images to find out that how many images are there. There is no images present, so I'm going to build a Docker image over here with the name of Simplilearn, or whatever the name you want to give. You can give it over here. In this case, it's not any kind of restricted word, so you can give the actual Docker image name also, that what for what purpose you are preparing this image. And with that, what will happen that it will take up the values, whatever attributes you have put up into the Docker file. So that will be processed and that will be picked up. And once that Docker file has been processed, has been prepared, you will be able to see that yes, a final product or a final Docker image is finalized and prepared over here in this one. So we just have to wait for the whole process to complete, and once my Docker image is prepared, I will be able to have a particular setup done or achieved over here. So that's what we require over here in this one to be performed. Now once the installation is done, so you will be able to see like the final Docker image is being prepared over here. So it says successfully built, which means that the Docker image is prepared. Now if you run like Docker images, you will be able to find out that this image is available over here in this one. Now you are seeing like two images, because one is like the basic image which is being pulled down, because we are using a Docker file to do that, to process that one there. Now in case you want to remove it, so all you need to do is that you need to run like docker image rm and Simplilearn. So if you do that, what will happen that your Docker image which is related to Simplilearn will be wiped off from your system. And in case you want to do like removal of the Ubuntu also, so that also you can do over here with the help of docker image rm Ubuntu, and that will be removed from your system. So your Docker images will be removed from your system using the particular command called docker image and then rm command to remove the Docker image from your system, from your host here. So that's how you deal with the different Docker images commands over here in this one. Now let's go back to the document.
Now the next section over here is the Docker container commands over here. So all the commands related to Docker containers is what we are going to talk about over here. Now the very first one is the particular container. So in order to create a container, so you can run the command called docker create and the image, because for a container you require a Docker image. That's a prerequisite. So once the Docker image is prepared, you can just simply run docker create command, and that will help you to create a container onto your system. Now if you want to run a particular you want to create a container and you want to run it also at the same time, so in that situation you can go for docker run command. The main difference between the docker create and docker run command is that the docker run command is going to run a container and it's going to give you a response from the command, but the docker create command is going to create only the container. So once the container is up and running, so that's only being done by the docker create command. But the docker run command is going to actually do the preparation of the container also, and at the same time you are being given as a particular response also, like what a command you want to run, so that response also you will be able to get here. And if you feel that you want to rename an existing container, so for that you can go for the docker rename command. So existing container, you can rename it with the new container, and that's how the particular rename of an existing container will be done with onto the docker host here. So docker rename is the command using which you can rename an existing container and you can get a new container over here in this case. So these are some of the options, some of the ways that how you can interact with the containers, how you can manage them onto your docker host over here. So you can run it, you can create it, and you can rename the containers also.
So now what we're going to do is that we are going to see that how we can work on this particular container commands here. So first of all, I'm going to quickly pull down a Jenkins image so that I can create a container out of that. So it's in kind of a 600 around MB Docker image which is available there. Now you can also have a custom Docker image prepared using the Docker file, or you can have a ready-made Docker image pulled down from the Docker Hub also. So this is going to pull the latest version of the Jenkins from the Docker Hub, so that we will be able to proceed further on that and we will be able to continue with the hosting. So we will be converting or running this specific Docker images in the form of Docker containers, so that we will be able to have an instance of Docker container over here running in this one. So that's what we are trying to do here. So we will just wait for this pull activity to complete, because it's an heavy Docker image, so it may take some time to download. And once it's download, you will be able to see that Docker images is showing a specific Docker image of Jenkins here. Now you're going to create a container out of that. So you're going to run a command called docker create and Jenkins over here. So that will help us to do the creation of a Docker container. And once that is done, so you will be able to see, like using docker ps command, that if any container is up and running, and if you go for docker ps-a, you will be able to see that yes, a particular Docker container is in created mode. Now this is not in running mode, because you see that when I ran the docker ps command, it was not showing it in the running mode, because I just created a Docker container here, and the created status also shows that yes, the Docker container is created, but it did not run over here. So if you want to run it, so definitely you can say like docker start, and you can give the container name, and that will help me to start my container over here. But of course, if you feel that you want to directly create a container, and you don't want to create the container only, you want to start it also, so in that case you can go for the docker run command. So docker run command is something which can be used instead of doing the execution. So you can say like docker run Jenkins, and what it will do, it will definitely help you to get the container created onto of the Jenkins over here. In this case, it's not like only creating a container, but in fact it's actually starting the container also. So you can see that it started over here into your screen itself, that whole Jenkins gets initialized over here in this one. So this is the way that how you can initialize or you can create a container. Now I can just do a control C over here, because it says that Jenkins is up and running. So you can start using this one according to your requirement over there, right? So I'm just doing control C so that it can be stopped over there, right? Now, so this is the way that how typically we can create the containers. Now we got like two containers over here, and one is up and running, and one is something which I just closed just now over here. Now if you feel that you want to rename a container, let's say like this is a container which is available, but it's not having a meaningful name. Now I want to convert it into a meaningful name like dev_Jenkins. So that you can easily do with the help of docker rename command, because that will rename the Docker container name, so that you will be able to connect on to that and you can go for the processing. So that's what we can get over here in this one. So this is how you can do the various management of the resources over here. So let's go back to the main content.
Now if you feel that you want to remove all the stopped containers, because what happens that sometimes we simply stop the container but we do not remove it from the Docker host, because we are not going for the cleanup. Now cleanup is very required because these containers are actually taking up the disk space also. So we need to make sure that we should be having like minimum amount of disk space utilization. So for that, what we really need to do is that we need to run docker container prune command. So this will basically help you to prune or do the cleanup, purge of all the containers which is running on the host machine here, and that will definitely help us to remove all the containers which is in stop status. So that will be simply removed over here in this one. So this really completely removes all the stopped containers onto the Docker host over here in this scenario. Now second one is that it creates a new image from a containers file changes. Now the way what happens that normally what we follow is that we use the docker build command to do the build process, right? So docker build command is being used in that particular way. Now if you really want to go for preparation of a new image, so all you need to do is that you need to create a new image from a container file. So you can run the command called docker container commit command, and whatever container is there, so that will be saved or preserved as a docker image. Because sometimes we also do some ad hoc changes or modifications on the fly inside the docker container by going inside the docker container and doing the steps. So we really need to preserve those steps, and that is the reason why we are converting a docker container in the form of a docker image here. So that's what we are trying to perform here. So docker container is something which is being done over here in such a way that whatever the steps, whatever the changes we are trying to do, so that needs to be performed over here in this case. So docker container commit command is being used so that we can get a particular final image as part of the container. So the container will be converted in the form of a docker image over here. And the last one is that how we can remove an existing container. So we can go for the docker rm command, which is available there, using which you will be able to go ahead and you can get a particular container removed from your existing system. So docker rm command is pretty much there, using which we can see that how we can remove an existing container from your system as such.
What exactly now we are going to see that how we can perform the various commands on the containers here. So the very first command which we want to do here is that in order to see that how we can actually remove all the stop containers. But for this one, what we really need to do is that we need to first of all run some couple of containers. So I'm going to quickly run a container called docker run -d httpd. So I'm going to run a particular web server over here, and it should be able to give me a proper container up and running. So I can just double check or validate it as with the help of the docker ps command. So docker ps command should give me the proper confirmation that whether the container is up and running over here or not. So you can see that it's up and running from last 11 seconds here. Now we got a command where for example we have got some stopped containers, but again you have to manually remove them one by one. Now if you don't want to do that stuff, if you feel that whatever the stopped containers which is available, that should be automatically removed from your system, then we have a command called docker container prune. Now for this, what we really need to do is that we need to actually stop this container, because again it will be only picked up like whatever the containers which is available in the stop status, only those will be picked up. So I have copied the container name here in this case, and I need to stop it so that I will be able to remove it with the prune command over here in this one. And then I can run like docker container prune command, which will basically remove all the containers which is in the stop status. And once that is done, you will be able to see like that is something which is completely gone from your system. So this is a way that how it can not only take care of the stop containers, but it's actually being done so that you can remove the multiple containers with a single command itself over here. So this is not something which will be executed one by one on a different container, but yes, it will definitely take care of doing the changes and performing the activities. Now another thing is that how we can actually do the commit of a particular docker image. Let's say that we got a docker container which is running, and there are some changes like some dynamic changes which is available there. So you want to save this particular container as a docker image, so that whatever the changes, temporary changes are there, so that will be also saved as a docker image. So all you can do is that let's say let again run a particular container of HTTPD here. So this will help me to get a particular container from the HTTP perspective available to us. So docker ps command will give me the option. Now here I have got a container in which it's running. Now if I want to save this container, let's say that I went inside it, did some modification, did some temporary changes. Now I want to refer it, I want to use it. So how you can do that? So for that, what you really need to do is you need to run like docker commit. That's a command, or you can say docker, because you're going to do a docker container commit over here. So the commit of the container is what we are going to do. So docker container commit, and then we are going to say like what is the container. So for container we will be, yes, again copying that particular container ID, and we'll say like custom image colon version 1. So we will be giving a custom name or a name of a docker image and a tag over here in this one. So this will basically save my docker container which is available in this one in the format of a particular docker image, in a format of a docker image over here in this case. So as you can see that almost both of them are having the same change, but the container which we got over here in this one, so this whatever the changes you want to do, you can do that, and you can then put it up into the form of a docker image, a final docker image. And at last, if you want to remove it, so docker rm and container id. Now this again docker rm will come remove only those containers which is in stop status. So if you want to forcefully remove it, so you will be able to use it with the help of -f, which is the forceful remove, which will remove the container completely from your system. And once it's removed from your system, you will be able to see like there is no container running up and running over here in this one. So docker ps -a is not something which is up and running over here in this one. So the completely got wiped out from your system. So that's how you basically work on these commands on this particular container related commands here. So let's go back to the main content. Right, so these are the commands where we can actually do the management, like how to stop the containers, how to remove the containers, and how to get a new docker image out of the container here. Now let's see that how we can list down all the running containers. If you feel that you want to list down all the running containers, then you can go for the docker containers ls command, and that will eventually help you to list down all the containers which is available there, which is being there into your system. Then docker stop command is there to stop a container. So whatever container which is there in the running status, so that will be stored with the help of the docker stop command. And then the restart command is there, using which you can do a restart of a container into your system. Right, so once the container is restart, so whatever the application running inside the container, so that will also be restarted over here in this one. So these are the different options which is available, using which we can explore over here in this one. Somewhat more commands about the container. So again, I am going to run a container over here of HTTPD here, so that I can show you some couple of more commands over here. Now we can run like docker ps, or you can say like docker container ls will be list down all the containers which is available to you, which is being present in this case. Now if you want to do any kind of operations, like let's say if I want to stop it, now the moment you do the stop over here, so you will be able to stop the container which is up and running for you, and you can come whatever the application is being deployed, that will also not be available to you, because that's simply completely gone for you. Now you can see that docker container ls is not able to show you that particular option, that whether it's being shown or not, because it's in stop status. So in fact you can do a start, or you can do a restart. So both the operations you can pretty much do over here, so that you will be able to have a complete activity implemented. So restart is also something which is available, which can definitely help you to see that how the things really work, and how you can go for the container the management over here in this case. So you can do docker container ls command to list down what are the containers which is available. Then you can do a restart, you can do a stop also. In fact, start is also there, which can help you to see that how the containers is really available. So this is the way that how you can manage like even the restarts and all, because this really helps you to even do the restart or bounces to the application which is present inside this container. So that also you will be able to see with this particular component here. So that, let's go back to the main content.
and then killing a running container. So if you really want to kill a container, so for that we can go for the docker kill, because docker stop is also going to stop the container. But if you want to forcefully kill it, so in that case you can go for the docker kill command to do that particular kill on the containers. And then if you really want to go inside the container and you want to attach your terminal, so for that you can go for the docker attach command, and with this what will happen that you can go inside the container, you can do whatever the changes you want to perform, you can do that, and you can again come back outside that also. So normally typically we use it so that we can see some errors of in the logs which is coming up in the containers, and if any kind of issues are coming up for the applications, we should be able to know that part. Now the last one is the particular wait. Docker wait is there, so that will block a container, and it will go in the wait status. So docker wait and the container ID or the container name you can give. So with that, the particular container will go into the block status. Let's see somewhat more commands over here. So we can run like docker container ls again to find out like what container is available. So you can see that this particular container is available over here in this one. Now if you see, like if I want to get attached to this container, if I want to attach my input and output stream with this container, so you can run like docker attach and the container ID. So your terminal will be stuck over here because it's taking up whatever the progress which is going to be done in the container, that will be in a kind of attached to your terminal over here, and you will be getting the output. But the moment you come out of this, like you say Control C, so you will see that it's basically sending the request to the container that it's getting stopped. So you will be able to see like the docker container list is not going to show you because the container is in stop status. So again you have to do the restart of the container to make sure that the container is up and running. Right, so the attach one will help you to go and attach your standard input and output with your container, with a running container. But when the moment you comes out, you will be able to disconnect or shut down the container. And again I had to restart that container over here in this one. Then again of course we have like docker wait, then container is there. So this will basically put the container into a block status, because all the requests and all will be not sent to the container, and it will be blocked. And if you really want to like consume, or if you want to make use of the container, you will not be able to do that. So docker wait command will kind of block the container, and if you again try to come out of that, so again the requests to the container will be resumed, and they will be able to use on that part. So docker wait command is being used to block the container, and then we have docker attach to the container, the standard input and output. And lastly is the docker kill, which is going to kill the container, and you will be able to see that the container is in simply killed status. So it's it's not like a stopped over here. If it's gracefully stopped, then the exit code definitely will be 0. But in this case, since it's being killed, the particular status is 137 over here in this one. So that's a non-zero status code. So that's how way you will be able to manage the containers on different aspects. Let's go back to the main container. So these were some of the commands which was there from the Docker containers perspective. Let's talk about some of the commands from the share command perspective. So how we can share the Docker images. So we have a typical pull push mechanism which is there, using which we can actually interact with the Docker hub or a Docker registry. So if you really want to pull a Docker image, so in that case you can go for the Docker pull command. If you want to push an image to the registry, so you can use for the docker push command. If you want to execute a command inside a particular running container, or you want to execute a command or a script or something like that, so you can go for the docker exec command, and with that the execution will be done and you will be able to get a response. So that will make sure that yes, whatever the execution you are trying to do, so that will be done over here in this mechanism. Now let's see that how we can do a pull and push activity to a Docker image. So first of all, the pull command is pretty simple. All you need to do is that you need to say that, okay, I want to pull a Docker image. If let's say that our Docker image is already present, then it's just going to say that it's already up to date, it's already available there. But if in some cases you feel that the Docker image is not available and you want to pull it, so all you can do is that you can give that Docker image name, and that you can give the tag also, but in this case we are using the tag as in latest.
So that's the reason why even if you provide or you don't provide, it doesn't really matter. So I'm going to give like a Docker pull a MySQL over here, and the moment I hit on this one, what will happen that it says this particular Docker image is not available into my system. It's going to download it, and once it's going to be downloaded, you will be able to see that into your local system. So Docker images is something which is going to help you with the commands, and it will give you the particular ways that how the Docker image is available. So I can run like Docker images over here to see that what are the different Docker images which is available in this manner. Now if you really want to move any of the Docker image, then of course you have to do a Docker login, and you will be doing the the connectivity to the Docker Hub, and then establish the connectivity and all. So what you need to do is that you can run the Docker login command. We will also see this command in the next particular slide, but right now we are just doing it because we want to showcase that how the push really works. So you can actually give your username, that what username you are holding up. So the password does not shows any activity, but yes, still it will let you know that whether the login is successful or not. So in this case, it says login is successful. So all you need to do is that, let's say like I got this custom image and I want to push it to the Docker Hub. So you need to rename, or you need to do a tag over here, because the same if you run Docker push custom image version 1. So if you do that, it will not be pushed into these particular Docker Hub. So it's going to throw error over here that the access is denied. So all you need to do is that you need to do a tag here. So you have to rename it in such a way that you should be able to add your username over there, because Docker Hub will identify that if it's there with your username, then only it will be pushed. Otherwise it will be simply rejected over there. So that's what you need to do. You need to rename your Docker image, the same Docker image which you have to append your username of the Docker Hub. And once that is done, so all you need to do is that you need to just run like Docker, then push is there, then this image name, and then version 1. So the moment you do this, what will happen that it will start transferring those Docker image to the Docker Hub. You see this specifies that yes, this is going to the Docker Hub, docker.io, where my username is there, and this is the custom image which is available there. So if I refresh my page on the Docker Hub, I will be able to see like this public repo which is available there. But again, this one does require the credentials and the login, which we did in just last command, where we ran the Docker login command to do the login to the portal, and after that only we are able to do the setup and the modifications over here. So that's how you do the login, and you are able to connect on that. Now these are some of the pull and push operations, but let's say that if you got a container which is up and running, like this is right now we are not getting any container which is available over here. So you can say like docker run -d httpd, like I'm just running a dummy container over here, so that I will be able to show you this command. Now if you for some reason want to go inside the container and want to see some processing and want to see some content, so you can run the command called docker exec -it, and there you can give the container ID. This is nothing but the full format of the container ID which is given to you, so you can use this one also, or you can use the shortened value also you can use. And in the last we can say like bash. The moment you do this, you will be going inside the container. You see that this is the host name which is being shown as the container ID. You can do a like ps-ef command, and it will throw an error that the ps command is not available, because you are running this command into the Docker container. So using these kind of commands which is not available in container will help you to identify that yes, you are not on the host machine, you are in fact into the Docker container. So that's the reason why you can do it, because for you the paths and all, everything is same, the terminal is also same, so you may not be able to differentiate in that part. So that's the reason why it's preferred that we use that commands which is going to fail, but that's okay. It will give you that okay, this command is failing because I'm into the Docker container right now. So that's what we are performing over here, right? And you can come out of that, but still the Docker container is going to be still up and running over here in this case. So the container is not going to be down over here in this one. So that's how we manage the container. We can go inside and we can check some informations and get some files there. So these are some of the commands where we can interact. Now, in order to log into the Docker Hub, because before doing the Docker push, you have to log in, you have to get a credentials and the connectivity with Docker Hub. So you can run the Docker login command where you can see that how the execution can be done. Now, using the Docker login command, you can interact with the particular Docker Hub. You can set up the credentials. Once the credentials is being set up, so what you can do is that you can go ahead and say that, okay, the configurations is done, and we can go ahead and we can perform the execution. So docker login is the command where you can give the credentials. Docker info is the command using which you can get the information about the Docker tool. So whatever the Docker info is available there, so those things you can actually get it over here in the case of the Docker info. So Docker info is going to give you complete information that what exactly you have the information available over here on this one. And then we have the Docker history. So using the Docker history, you can see history of the Docker image, that what exactly the mechanisms or what are the different image IDs are available there. So this is basically giving you the complete history on how the Docker image is prepared. All the commands is available there, and that will help you to eventually go and understand that how the images can be going on, and you can manage on that part. So these are some of the couple of options which is available there, where we can see that how the executions can be done, and we can go ahead on that particular part. So Docker history is the command again which will help you to see that how you can go for the particular mechanism, and you can listen on the things over there. So Docker login was already done previously when we tried to push the image, but again, if you try to run Docker login, you will be able to do that. Now Docker info is something which will give some additional information about the Docker, and all the informations about the Docker will be given back to you over here in this one, so the complete clarity. Then let's say that you got a Docker image called HTTPD. Now you want to check the history of this image, that how this image is prepared, what are the different layers which is available, how many layers are there, how much size is being modified in each and every layer. So you can see that we got a layer where we have particular changes of 7.838 MB, but pretty much the from the complete size of this HTTPD, the major portion is actually of the this one, the basic operating system which is being implemented. And then of course there are some packages which got deployed, due to which this 60 MB and 7 MB size is coming up there. So this actually gives you the complete layer wise mechanism, that what are the informations which is available, that how the modifications actually got modified and got changed over here in this one. So this is the additional help which you can get from the Docker to manage the containers here. So these are the ways where you can interact with the Docker Hub. If you really want to create a volumes for the containers, so you can go for the Docker volume create command. So Docker volume create command is there, using which you can create the Docker volumes, and you can pretty much do that setup. So Docker volume create is the command which is available there for that particular part. It will create a volume for you. Now let's see that how we can actually work with the volume. So you can run the command called docker volume ls to find out that what are the different volumes which is available there. Now if you really want to create a volume over here in this one, so you can say like docker volume create, and you can go for the volume name here. Now the moment you do that, what will happen, that a volume will be created, and you can validate it with the help of docker volume ls command, that whether the volume is being created or not over here. So this is the way that how you can manage the volumes onto the Docker host. Now let's talk about some of the docker swarm commands here. Now docker swarm commands is there to set up a particular mechanism where you can see that how you can perform a setup. You can actually go here and see that how the setup and modifications can be done. So docker swarm is there where we can see that how the execution needs to be done. So you can go for the command called docker swarm init command. This will actually go for an initialization of a docker swarm cluster, and once the docker swarm cluster is initialized, then you can pretty much go there and perform whatever the executions you want to perform. You can do that, and you can execute as such over there. So docker swarm init is the command using which you can actually see that how the execution needs to be done, and how we can perform the mechanism and the changes over here. So docker swarm init hyphen advice adr address is there, which helps you to see that how the executions can be done. Now joins, you have the docker swarm join command which is available there. Now if you go for docker swarm join command, so you can have a particular host. So Docker swarm join command is there, which you can run on the node machine, and in that case what will happen, that node will be a part of the Docker swarm cluster. And then if you want to leave from the swarm cluster, then you can go for Docker swarm leave command, and it will be simply removed from the Docker swarm cluster there. Some of the couple of commands using which we can initialize or we can remove from the Docker swarm cluster here. So Docker swarm is already being initialized, or is being created when the moment you do the installation of Docker. So Docker swarm init is the command using which you can initialize a Docker container. Now once you initialize over here, so after the initialization, you got a command which you want to add it, like you want to run it onto the Docker swarm cluster. It will act like a worker node, so that you will be able to deploy the containers on top of that. Also, if you want to join it as a manager, so you can also get the join token again, so it will give you the proper command. Now if you run like Docker node ls, so you will be able to see like what are the different nodes which is available there. And for any reason, if you're not comfortable with that and you want to reinitialize your Docker swarm cluster, so all you can do is that you can say like Docker swarm leave -f, and you will be left out of the Docker swarm. And now if you want to run like Docker node ls, you will not be able to get that output, because it's saying that there is no particular swarm manager which is available. So you can run Docker swarm init, or you can run the join command to connect to that specific node, but we have already left it, and nothing is available over here. So that's a way that how you can manage like what are the different Docker swarm commands we can typically run to manage the Docker swarm cluster. Now let's talk about the Docker compose commands. Now Docker compose commands is actually there using which we can create multiple containers. It's not only one container which we can create, go for multiple creations of the containers with the help of Docker compose file. So Docker compose -version is the command which we can give you the version of Docker compose which is being used. So here we use a particular YAML format file which will help us to create the multiple containers. We define the services, that what are the different containers we want to create here, and then with the help of a docker-compose.yaml file, we can create, or we can have that particular Docker compose file set up over here in this case. So docker-compose.yaml file is used to do the setup and the modification, so that you will be able to have the modifications done, and you will be able to find out a particular multiple containers gets created all together. So Docker compose is the way that how you can do the setup. How you are going to run the Docker compose file? So in that case, you're going to run the docker-compose up command, which will help you to set up like how the compose can be done. And once you are done with the docker-compose up command, so using this, the compose will be done and the containers will be up and running. So these are the commands using which we can manage multiple containers using the Docker compose one. So let's try to run some commands related to Docker compose. So docker-compose version will let you know that what exactly version of Docker compose is installed into your system. So you can run typical apt command to do the installation. So docker-compose is the package name which you can install, so that the executables and the package can be installed into your system onto the server. Now all we need to do is that we need to create a Docker compose file. So what we need to do is that we need to create a docker-compose.yaml file is the default name of the YAML file which we want to create here. That's a standard name. So once you create this, all you need to do is like you need to put some values, attributes. The very first one is the version value, that what version of this particular attribute you want to create here. Let's say that I want to create a version 2. So I will configure here that yes, the version 2 is what I require. I want to set up over here in this one. Now again, if I want to configure that what are the different services we want to run, because services is the main thing which we will be running on this machine, on this server here. So that's what we require. So then we need to put for a particular service called web. So web service we want to search and we want to run. And then again, we need to take care about the spacing, because that's a very important part. And we need to provide the values of the image and all these configurations here, so that you should be able to set up like how the images and how the Docker images can be built up over here. So web is the service which we want to deploy, and then of course the image is the attribute which is there for the web, that yes, Nginx is the one which we are trying to build up. Now you can give the ports configuration also, so you can say like ports, and inside that you can say like what port mapping you want to perform. So you can say like 8080, so or sorry 80 is what you can dash for the Nginx because it runs on 80 port. But now I have to run like 80 port. I want to dash that port over here in this one. So I can specify that 80 port should be available in this one. So I'm going to save this one here and I'm going to run a command called docker -compose up. Now this will run the containers in the interactive mode, but if you feel that I want to run in the detached mode, so you can say like -d also, which will of course run these ones into the detached mode and it will be executed. So it will process your docker compose file, and since you have used a standard name called docker-compose.yml, so it will automatically pick that docker details and start creating the container.
As Angular is a front-end framework, we'll be using a web server called Nginx to serve the application HTML files. After this session, you will understand three things. First, what is Docker and what is it used for? You will understand the basics of Docker and what problem Docker fixes. Next, you'll learn how to write a Docker file, which you can think of as the recipe Docker uses to build your image. In this session, we'll be using a multi-stage Docker file to build our application. Third, you will learn how to use an Nginx server to serve an Angular application inside a Docker container. To follow through the examples in this session, you should have an Angular application ready and the latest version of Docker installed on your workstation. You can install Docker by following instructions on docker.com. First, let's look at what Docker is. Docker is the most popular containerization technology, and it has quickly become the de facto standard when talking about containers. Containerizing an application means packaging it and all its dependencies into a single, easily transportable and isolated container. This container will run in exactly the same fashion regardless of the computer it is run on. By providing this layer of consistency, Docker fixes the traditional "but it works on my machine" problem. Instead of distributing just our application, we're distributing a full runtime environment along with our application. While not exactly correct, it might help you to think of a Docker container as a lightweight virtual machine inside your computer. Your computer can run multiple Docker containers at the same time, stopping and starting them individually as required. A common problem in software delivery is dependency management. When one application is run on multiple development machines and multiple server environments, a small difference in the version of an external library can change the functionality of your application, making it behave differently on different environments. The beauty of Docker is that if you build your application into a container image and transfer the same container image to your colleague's computer, you can be sure that the application will function identically on both computers. This is because the container includes all dependencies for the application inside it. On the other hand, a Docker container should not have any dependencies to the host it's running on, apart from Docker itself. It's important for you to understand what images and containers are, and what's the difference between them. For the purposes of this session, you can think of a Docker image as something that holds a file system and some metadata in it. The metadata includes things like the name or tag of the image, and instructions for Docker like what command to run by default when the image is started. While the official Docker documentation is a bit vague about the meaning of names and tags, you should learn the basics of it. Every Docker image has at least one tag, and in fact, the same Docker image can have multiple tags pointing to it. Every image tag has a name part and a version part, separated by a colon. For example, the Nginx image has multiple tags representing different versions and different flavors of the image. There's a special version tag called latest, which points to the latest version of the image. All Docker commands default to using the latest version tag if no other version tag is explicitly defined. When you build an image on your local machine, or for example a build server, you can upload the image into a Docker registry. When you configure other machines to use the same Docker registry, you can download the same image to as many other machines as you like. There is an official Docker registry called the Docker Hub, and the model is the same as, for example, GitHub. You can store public images free of charge under your account, but you will need to pay to host private images. Having your images public is great for hosting open source projects, but for any commercial proprietary applications, you will most likely want to opt for hosting the images privately. If you don't want to use a third-party service, you can always run your own Docker registry. My advice is that unless you're planning on hosting a very large number of images, it's absolutely worth the cost to spend a few dollars per month on a hosted Docker registry, such as Docker Hub. Once your application ecosystem starts to build around Docker, the registry becomes a critical piece of infrastructure, and keeping it up and running can prove to be a substantial piece of work. When you build or download a Docker image to a computer and run it, it becomes a running container. If you don't tell Docker otherwise, Docker will run a pre-specified command inside the container. As far as this command is concerned, it is running inside a Linux server, and it has access to other commands and resources that are available inside the same container. You can think of a container as a sandbox, where processes running inside the container do not have access to the host system or other containers unless you explicitly specify otherwise. Note that the complete container runs around a single process created by the initial command used to start the container. If this process terminates for any reason, the container will stop. An example for our container would be the Nginx server process. When you start a container, the Nginx server process starts in it, and when the Nginx server process dies or is killed, the container will stop as well. It is possible to run multiple processes inside a single container by, for example, using an init system to spawn the processes you need, but for the purposes of this session, we'll use the concept of just a single process per container. The basic workflow with Docker is as follows. First, you will build a Docker image either on your workstation or on a continuous integration server. Second, you will push this Docker image into a Docker registry to make it available for other computers. Third, you will most likely want to run the image on a server that is accessible via the internet, so clients can access whatever server software is running inside your container. Most often this is an HTTP server, and in this session we'll be using the Nginx HTTP server. In software delivery environments that embrace continuous delivery, this workflow is often part of a fully automated pipeline. A pipeline like this can trigger from committing a piece of code into a version control system and thus automatically deploy a new version of your application into a testing or even production environment whenever you change your application code. As we discussed earlier, a container is isolated from the machine it's running on, as well as any other containers running on the same machine, unless you explicitly define connections between them. This is out of the scope of this session, but I recommend you spend some time after the session to learn about Docker networking and links between containers. In this session, we'll be running a single container that can connect to the internet through the host machine and expose a single TCP port for the Nginx server process. Building Docker images is done with Docker files. You can think of a Docker file as a text file containing a recipe to tell Docker how to build an image. The basic function of a Docker file is to be a list of instructions that incrementally manipulate an existing Docker image. The word existing here is important. While you can theoretically build a Docker image from scratch, in most use cases you will actually be using another Docker image as the base for your new image. Many frameworks and open source projects publish their own Docker images, which can be used by developers to build images on top of. In this session, we'll be using a new Docker feature called multi-stage builds. This feature is available from Docker version 17.05 forward, and it allows you to use one base image for building our application and another base image for serving it. This works brilliantly for our use case. While Angular is often used as part of the full mean stack, in this session we're only concentrating on Angular. I'm assuming you know Angular and how the Angular command line interface works, and that you have a package.json in your application directory. If you're not quite there yet, check out the excellent Getting Started guide on the Angular website. Please note that the functionality of Angular varies wildly between major versions. However, the fundamental idea behind containerizing an Angular application is the same. Our Docker file is going to have two stages. First, we'll need to build our Angular application using the ng-build command. This will output the packaged application in the dist directory under our application root. In the second stage, we will place the files from the dist directory into a directory that's served by a web server, and finally run the web server itself. This is where the multi-stage build feature comes in handy. As you remember, a Docker container only has the software available which we've explicitly added into it. This means that for the ng-build command to work, we need to have the Angular command line interface installed inside our Docker container. This is something we wouldn't want on our final Docker image because it's just extra weight. And on the other hand, we wouldn't want the web server inside the image we're building our application in. Because the Angular CLI is distributed as a node package, we can use the official node Docker image as the base of our first builder stage. Because Angular is a front-end framework, it doesn't come with a server-side component, other than the test server shipped with the Angular CLI. Unfortunately, this test server isn't fit to be run on production, so we'll want to use something else to serve the Angular HTML files. In this example, we will use a robust web server called Nginx to serve the Angular application. Please note you could just as well be using a server application like Apache or Lite instead. I'm not going to be diving into the specifics of configuring Nginx. Nginx does come with good documentation, but more importantly, it also comes with an official Docker image. We can use the official Nginx Docker image as the base for our Angular application image. The good thing is that this makes our Docker file very short and simple. Let's have a look. This is the Docker file, and it's divided into two stages. The way the multi-stage build works in Docker is that we're actually creating multiple Docker images with a single Docker file, but we're only keeping the last image we've defined. This allows us to build the application first and then copy the resulting build artifacts into the next Docker image. The idea behind this is that our final Docker image won't have all the build time dependencies in it, which makes the resulting image nice and small. In the first stage, we'll use the from directive to instruct Docker that we want to use the Node 8 image as our base image. We're also using the asBuilder keyword, so we'll be able to reference this stage in our second stage later. The next directive is the copy directive. This command is for copying files and directories from our local machine to the Docker image. We're giving this directive two arguments: the location of our application code directory and the target path within the Docker container. In this example, our application code sits in test app, and we want to place it in the directory test app inside the container. The next directive is workdir. This tells Docker that all following commands should be run within the specified directory, which in this example is the application directory within the container. The next directives are the run directives. As you might guess, these directives instruct Docker to run commands inside the container. First, we're running npm install to install all node packages defined in the package.json file of our application. Then we're running ng-build to package our Angular application in the dist directory. Now we'll get to the second stage, which is copying the contents of the dist directory into a directory that's served by default by Nginx. We're using the from directive again. This tells Docker to start building another image. We're defining the from image to be an image called nginx, which is the official Nginx Docker image. This image is pre-configured to run the Nginx server and serve HTML files that are stored in a predefined directory. Next, we'll use the copy directive, but this time with the from argument. This tells Docker to not look for the source path in our workstation, but instead the previous stage in this Docker file. Essentially, we're copying the contents of the dist directory in the previous Docker image into a directory called user share nginx html inside our new image. The nginx Docker image will then serve the contents of this directory. Finally, we're using a directive called expose to tell Docker that the port 80 has a server running in this image. The port 80 is the default HTTP port, as you might know. Note that the expose directive alone isn't enough to actually expose the port when the image is run. You can merely consider this as a documentation feature, and will still need to explicitly map port 80 from the container into a port on the host machine. This enables you to connect to the mapped port on the host machine, which will then forward the connection into the container. To follow this session for your Angular application, create a file with these contents and place it in the parent directory of your application code. Remember to customize the paths in the file accordingly. Make sure the name of the file is Dockerfile written as one word with a capital D. Now that you've learned what a Docker file is and what one looks like for an Angular application, let's learn how to use it to containerize an example Angular application. For this, we'll be using the Docker command line interface. After you've installed Docker on your workstation, you can use the Docker command line interface to build and run images. To find the command line shell on a Mac, click on the Spotlight search icon on the top right corner of your screen and write Terminal followed by Enter. While the Docker command line provides many features, in this session we'll concentrate on two, the Docker build and the Docker run commands. First, let's navigate to the directory with our Docker file. The command we'll be using is docker build. We'll be giving the command the -t argument, which defines the tag for the image that will be built. For this, we'll be using the tag test app. The second argument for the docker build command is the build context. This is where Docker expects to find the Docker file. We'll use a single dot to denote the current directory and press Enter to start building. You can see Docker runs through every directive in the Docker file as a step, outputting the directive and the output of running it. Finally, you'll see that Docker has successfully built the image and tagged it as test app latest. As you might remember from before, since we didn't define the version tag, the tag latest is used automatically. Great work! Now, let's run the image we just built. For this, we'll be using the docker run command. We'll be giving the docker run command a few arguments. First, -i and -t to denote that we want to run the image in an interactive terminal, that is, running the container attached to our current terminal session so we can see the output and interact with the process. We'll also be using the -p argument to map the port 8080 on our workstation to port 80 inside the container. As you remember, the Nginx server is listening on port 80. With this mapping, anyone connecting to port 8080 on our workstation will get forwarded to port 80 inside the container. Finally, the last argument is the tag of the image we want to run. We're using test app :latest. Now that the container is running, let's use our web browser to navigate to port 8080 on our local machine. And we can see our Angular application being served. Well done! You can see that Nginx by default outputs all the requests in the standard output of the container. After you've finished testing, press Ctrl+C in your terminal to terminate the Nginx process and thus kill the container you were running. And that's how you Dockerize an Angular application. Before you go, 3 takeaways. 1. Using Docker makes it easy to ensure that your application runs consistently on different workstations and servers. Secondly, Angular is a front-end framework. Angular needs a separate web server software for serving it. Nginx is a fast and robust choice. Finally, using multi-stage Docker files enables you to streamline your build process and create slim Docker images.
So if you are looking to become a Docker expert, consider the postgraduate program in DevOps by Simplilearn to gain expertise in Docker. This program offers blended learning that combines live online DevOps certification classes with interactive labs that will give you hands-on experience. You will gain expertise in the tools like Terraform, Maven, Ansible, Jenkins, Docker, JUnit, Git, and more. We prefer 1 year of prior experience to enroll in this course. So why wait? Enroll the course from the link in the description box.
Why exactly the Docker networking is it important? Let's talk about some scenario over here. So my application is something which totally works perfectly fine into my system and there is no issues on there. I ran it perfectly fine and I got the response. I'm able to interact, everything I'm able to do. But the same application does not work on the other person's system. Now what could be the issue? Because it's working on one machine and it's not working on another machine. Now the application does not work on another system because there is a difference in the computer systems. Maybe one system is having a different machine and another system is having a different machine, and you may be having some of the differences maybe in the term of hardware, maybe in the terms of software. So the differences are possible in 2 different machines. So how we can get a solution that we don't get this kind of problems, and once the container is prepared, it should be able to run it across different systems. So Docker networking is the ideal solution for this problem over here. With Docker networking, the application works totally fine, and it's something which can work on any system. You don't have any dependency that it will run only on a specific machine or a particular system. So what exactly is in Docker networking all about? So Docker networking enables a user to link a Docker container to as many as networks he or she requires. So you can actually connect a Docker container to a specific network. The Docker networks are used to provide complete isolation to the Docker containers. So you can have it like, okay, I want to run some couple of containers in a different network and another containers I want to run it into a different networks. So you can do that isolations, and the whole purpose of doing that isolation is so that we will be able to have a proper networking and proper executions and all that stuff. So Docker networking is a very important concept when we talk about or when we come up with the interaction or having the Docker containers isolated. So it resolves most of the problems. Okay, so you can have like multiple containers in running in same network. You can have different particular networks also there. So a specific network have its own attributes, and then you can use those attributes to connect to that containers and to access that containers. But the whole idea is that the containers are something which is specifically running in a set of servers or in a set of platform. So whenever I'm trying to look forward to that particular container, it has to be there into a network. If you don't run it into your custom network, then whatever the default network present, it will be hosted in that network there. So how does the Docker networking actually works? So you got a Docker file. So using the Docker file, you got a custom Docker image, and from this Docker image you have to actually go there and put up like the Docker container. So you can also store this Docker image to the Docker Hub so that the same Docker image can be shared across different users, and they can also pull down their Docker image and they can have the container running in their systems. So for the collaborating the Docker image, you require the Docker Hub, and the container is the ultimate thing or object which we need to create out of the Docker image. When we go with the particular process, when the whole process goes on over there, so what happens that instead of the Docker Hub, you can use your own private repositories also. That's something which totally relies onto you, that how exactly those things works on. So a Docker file creates a Docker image using the build command. A Docker image contains all the project source code, all the dependencies. Using this Docker image, you can actually run the source code in order to get a Docker container. The moment you initialize or run an instance of Docker image, you will be able to get a Docker container. You can actually use the Docker Hub for collaborating or for sharing the Docker image. So you can store the Docker image on Docker Hub, and then different people can actually go ahead and download or pull this Docker image onto their system, and they can also run their specific containers. So what are the different advantages we get with the Docker networking? Very first one is the rapid deployment, portability, better efficiency, faster configuration, scalability, and the security over here. So these are some of the advantages which we get when we talk about the Docker networking here. Now let's talk about the container network model here. So what is the network model we are looking forward from the containers perspective? Now this is a kind of a architecture here. Now in this one, let's see that how it actually works on. Now you have a Docker engine, which is a main component which takes up all the things, and all the important components are actually integrated with each other. Now the network sandbox is the one in which you will be having your container running up and running. Now every network is having its own attributes, the particular different gateway IPs, the IP addresses, the range of IP address, the CIDR blocks, also everything can be different for two different networks. So the whole point is that you will be defining, okay, if you don't define that I want to run this particular container into a specific network, then definitely that's going to run into a default network which gets created the moment you do the installation of Docker. But anyhow, any network is required for running a Docker container. So there are different network drivers which is available there. So if you feel that you want to create a network, so you have to choose a particular networking or the connectivity over there, and it really helps us to understand that how the configurations and how the different modifications and those changes can be really done here. So a lot of changes are actually going on and performing there, and this really helps us to understand that how the things are being done as such over there. So network is something which is very important from the containers perspective. So the network sandbox is an kind of a isolated sandbox that holds all the network configurations of the containers. So you will be requiring at least one Docker container network if you want to run a container in that particular sandbox. So sandbox is created when a user requests to generate an endpoint on the network. So that's where the sandbox gets created. It can have several endpoints in a network as it represents a container's network configurations like IP address, MAC address, DNS name. So every container will be having its own unique IP address, right? So that can be a particular endpoint to connect to that container, and it can have it like different endpoints and different networks. So that's always the possibilities which is available there. Now the endpoints establishes the connectivity for the container services with other services also. So the moment you work on the particular endpoints, so that can be used for having, okay, there is a service running in a container, so how you can do that. So in order to connect that, you require these endpoints so that you can establish the connectivity with the container services, whatever running inside these Docker containers. Right now, the network is something which provides the specific underlining network attributes like the networking support to the Docker containers, because these network sandbox boxes will definitely have a requirement of the network. So how you're going to get that you will be only able to get when you go, okay, I will be looking forward for the connectivity, and I can go for the communications, and I can give the hardware, because although it's a OS level virtualization, but still you require some interaction with the hardware from the networking perspective. And then Docker engine is the base engine which is installed on the host machine, and it's actually the main component which makes sure that the Docker containers and the corresponding Docker services are always up and running. And the using the network drivers, you can actually create multiple networks onto your system, and you can have those configurations. Now the network architecture is something which helps us to provide the connectivity among the endpoints, that probably belongs to the same network, and it's something which is a kind of isolated network. So different networks can be isolated networks, and we can have the endpoints to them. So there are different ways in which we can establish the connectivity, and this is a complete network architecture which is there. So you have a network drivers, you have the networks, you have the network sandboxes in which internally the Docker containers are running, and then these network sandboxes are having their respective endpoints there to access them to establish the connectivity. Now let's talk about the network drivers. Now there are 5 type of network drivers which is available. First one is the bridge, host, none, overlay, and Mac VLAN. So these are the different particular network drivers which is available over here. First one is a bridge. It's a private default network created on the host. If you go there, if you go to the installation of a Docker, this is the default driver which gets installed onto the system, onto the host. The containers linked to this network will have an internal IP address through which they can actually communicate with each other. On the same machine also, you can establish the connectivity. You can connect to the containers using that private IP address, but outside the server you will not be able to have the communication. But internally you can connect to the containers, and containers can also interact with each other. They can also communicate with each other with this one. The Docker daemon creates the Docker 0. So if you run the ipconfig or if config on the system, you will be able to see a Docker 0 kind of a Ethernet bridge network which is created, using which you can see that, okay, this is the network which is created by default. It's a default installation or default configuration which automatically happens the moment you set up a Docker instance. So you don't have to go into the configurations or in the setup of there. It will be already available on that particular installation mode there. And the next one is the host one. So it's a public network. So when we go with the public network, it's actually uses the host IP address and a TCP port in order to interact with the service running inside the Docker container. So if you are looking forward that I want to reach out or I want to connect to the container, but I want to use an IP address which can be accessible from outside world, probably some other server should be able to resolve that. In that situation, the host network driver comes into the picture. So it effectively disables the network isolation between the Docker host and the Docker containers, which means that using this driver, a user can actually run multiple containers. It's not possible for the user to run multiple containers on the same host because of the fact that you are using the host IP address. Now when we were talking about the bridge connection, at that moment of time we were getting the private IP addresses which was totally isolated and totally unique. So there were actually, if you create using the bridge connection multiple containers, so you will see that if there are 5-3 containers, everyone will be having a different private IP address. But the moment you go for the host one, so in that situation the IP address is not going to change, so you get some restrictions, okay, because the combination is of IP address and port. So IP address and 8080 can happen only once. It cannot happen multiple times. So that's a limitation, that you cannot run multiple containers on the same host due to this restriction. And next one is the none. So in this network driver, the Docker containers will neither have any access to the external network, or it will not be able to communicate with the other containers also. Total isolation and total private containers are being done when we use this driver. So if these options are usually used when you want to disable. So this is not doing nothing but disabling the total networking functionality for a specific container. That's what is happening over here. Next one is the overlay. So this one is utilized for creating an internal private network to the Docker nodes in the Docker Swarm cluster. So overlay does not comes up in case of a standalone Docker installation. The moment you go with the particular Docker Swarm cluster, at that moment of time the overlay type of network is created. So Docker Swarm is an orchestration tool, so that requires a overlay kind of driver which can help them to achieve the networking in case of cluster, because in case of Docker Swarm you have a master node, manager node, worker nodes, different machines are there. So in that situation, overlay is the main component or is the main type of driver which is used. And then we have the Mac VLAN, so it simplifies the communication processes between the containers. This network assigns a MAC address to the Docker containers. With this MAC address, the Docker servers will route the network traffic to a router. So it's not on the basis of IP address, it's actually on the basis of MAC address. So on the specific MAC address, the network, the Docker server will redirect the network to a specific router. Right, it's usable when a user wants to directly connect the containers to the physical network rather than the Docker host. So that's where this communication works on. So it's a direct connectivity between the host network and the Docker container. So there is no virtualization which is happening over here. So it's something which is giving a direct access to the networks, but it's definitely on the basis of MAC address on which the communication is happening. Now let's talk about the networking implementation, and we'll see that how we can go for a particular bridge network implementation there. So let's go back to the virtual machine. So I am connected to a particular system here, so I can check that if the Docker is available to me, and I can just run the Docker version. So it says that okay, the client and the server component both is available there. Now we are going to see that what are the different containers which is what are the different Docker containers network which is available there. So I'm going to run a command called docker network ls. Now the moment you do it, over here you will see that none, host and bridge, these are the different containers network which is available there, and you can see their network IDs, the names, the drivers. The drivers is also very important because that's what we are going to use here, so it's a very good one here. So the default one, you can see that the bridge is available, and it's a default one whenever you create any container. By default, whether you give the container attribute or not, it's something which gets created into the terms or in the basis of the container only, in the default network only. So how we can get that? We can always get that part by having the understanding that what network we are using. So I'm going to run a couple of containers or small container, and we can see that how exactly the containers can be executed and can be done over there. Right, so let's see. So I'm going to run a command, docker run -d it -name alpine1 alpine image is what I am going to use, and sh. So it pulls down the alpine image. That's what it happened, and the same thing I'm going to run, but this time I'm going to run alpine2 because I want to create two containers. Right, so with this one, what will happen, that I will be having two containers available here. So I can say like docker ps, so I can see that two containers are running, one is the alpine and one is the alpine2. Right, so now what happens, that we will see that how the connectivity happens and what are the network details. So what I'm going to do is that first of all I'm going to do an inspect over there onto the bridge connectivity so that I can get the detailed information. So this is the name of the particular ones of the network. So this is the network which is available, and this is the default one. So if I scroll up, you can see that this is the name of the bridge connectivity, and even if you run the docker network ls, so you will be able to see that the ID also. So ID also, if you compare, so E65, that's the one which is available. Now this one is something which is using a driver called bridge, and here you can see the subnet information. Now if you scroll down, you can see that two containers are available here. So I did not provide any kind of network details, but definitely what happens that the two containers which I deployed are basically running inside this network. Okay, and you can see that the bridge name docker0 is the internet network which gets created which during the installation of docker gets configured. Now you can see that this is the IP address, this is the IP address here, this is the MAC address, and this is also a MAC address here. So the IP address, you can see this is a 3.0.3 in the last, and this is .2 over here. So you can see that the sequence is there. So Alpine 1 was having an IP .172.17.0.2, and Alpine 2 is having an incremented IP address like a different one as in 3. So you can see that these different IP addresses are there, and represents if you want to access them, if you want to connect on them, you will be able to have the connectivity accordingly. So even if you go inside these containers, you can actually see that what exactly the connectivity you want to establish or the connectivity you want to perform here, right? So this is the way that how the network usually works, and the networks bridge you are using over here is the bridge ones, which definitely helps us to understand that how the configurations can be done. Now, so what we are going to do over here is that we will try to see that how exactly we can go ahead and we can connect on there, and we can also see that if we are able to communicate with each other, because probably if I run like ping command over here, and I'll put the containers like 2, and I'm able to reach out. There is no problem in reaching out to these IPs because these are the private IP addresses, and I will be able to reach out to them without any problem and without any concerns. So from the current connectivity perspective, there is no problem as such, and I have a connection available over here. But let's see, we'll go back to the containers. We'll see that how exactly we can talk about, we can reach out the one container with each other. So I want to connect Alpine 1 with Alpine 2, so how we can do that? So I'm going to use like Docker Alpine 1. Okay, now I got a terminal. So what I can do is that I can go for the IP and just show. So with this one, what will happen that I will be able to know the IP address. So .2 is the one which is available over here. Okay, so this is the IP address. Now I can simply do the small ping command. So I can say like ping google.com, so that will show me that if I have an internet connectivity, so that is great. So I got a connectivity with the internet over there, so I will be able to reach out any websites or any kind of that order. Now I have another IP. So .3 is, remember we were using different IP, so I can actually do a ping also here. So ping -c5 request will put, and 3 will do here. Now we are trying to reach out to the Alpine 2 over there. So although we are connecting to the Alpine 1, but we have the connectivity with Alpine 2 also. So from Alpine 1, you can connect to the Alpine 2 containers. So that shows that since both of them are running in the same container, so they are having the automated connectivity, and you can easily reach out to them, and without any issues you can do that. And similarly, the same thing you can do it in case of Alpine 2 also. So you get it connected to the Alpine 2, and you can just follow the same thing. So you can connect it with the, if you go to the Alpine 2, you can connect to the Alpine 1 also. So if you come out, the containers will be always up and running, and you will be able to have the mechanisms there. So the whole idea about these things is that it will be basically helping you to understand that how the executions can be done and how we can perform the activities as such over here. So this is the way that how we deal with the networkings and how the containers gets created into a network, and then they can interact with each other.
Docker. But before we jump into that, I want you to hit the subscribe button so you get notified about new content as it gets made available. And if you hit the notification button, that notification will then pop up on your desktop as a video is published from Simplilearn. In addition, if you have any questions on the topic, please post them in the comments below. We read them and we do reply to them as often as we can. So with that said, let's jump into Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker, and we can actually go through and understand what the problems specific companies have actually had and how they're able to use the two different tools to solve them. So our first one is with Bose, and Bose had a large catalog of products that kept growing, and their infrastructure had to change. So the way that they looked at that was actually establishing two primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after After going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the #1 container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising, because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. As I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it, and you should be able to look and see whether or not you can add your own company to this list.
Did you know the famous global researcher Gartner predicts by 2023 more than 50% of the companies will be adopting Docker containers? However, a serverless container like Docker will have a rise in the revenue from a small base of 465.8 million in the year 2020 to 944 million in the year 2024. In this video, we will be doing a side-by-side comparison of the Docker containers and the virtual machines. But before that, let's have a look at the objectives of this lesson. In this session, you will have a good understanding of what a virtual machine is and what a Docker is. Followed by that, we will have a major difference between Docker and the virtual machines. Also, we will discuss some of the key differences between Docker and virtual machines. And finally, a use case on what made BBC to use Docker. So the first one, what exactly is a virtual machine? It is an isolated computing environment that enables a person to use an operating system via a physical machine. Virtual machines provide the functionality of a physical computer. As you can see on my screen, there is a virtual machine, and this is how a typical virtual machine looks like. Now, let's look at what a Docker is. Docker is an operating system level virtualization software platform that enables software developers and IT administrators to create, deploy, and run applications in a Docker container with all their dependencies. And a Docker container is a lightweight software package that includes all the dependencies like frameworks, libraries, and many more, which are essentially required to execute an application. This is the architecture of Docker tool. Now let's move on to our next main topic for the discussion, that is Docker versus virtual machine. When it comes to comparing the two, we could say the Docker containers have much more potential than virtual machines. As you can see on the left and right hand side, both the images look similar. Now let's define the layers of virtual machine from the bottom up. Let's begin with the infrastructure. Infrastructure could be a computer system, a laptop, or a virtual private server such as an Amazon EC2 instance, or Azure virtual machine, or GCP virtual machine instance. On the top of the infrastructure runs the operating system. An operating system is a software that manages hardware and software resources for the computer programs. On your laptop, this will be likely Windows, Mac OS, or Linux flavored operating systems such as Ubuntu. Next comes the hypervisor. A hypervisor is a firmware that builds and runs virtual machines. There are two types of hypervisors. Type 1 hypervisors are HyperKit for Mac OS, Hyper-V for Windows, and KVM for Linux operating systems. And Type 2 hypervisors are VirtualBox and VMware. Then we have the guest operating systems. Consider an example where you want to run two apps on your server in total isolation. This process would require two guest operating systems which will be controlled by a hypervisor. Virtual machines come with many dependencies, where each guest operating system will at least occupy 512 MB of your RAM. This is worse because each guest operating system needs its own CPU and memory resources. Eventually, this will be expensive. Then, on top of that, Each guest operating system requires its own dependencies, such as binaries and libraries. Since every application has different dependencies, it requires its own set of libraries. Finally, it's the application. This layer consists of the source code for the application you have built. This was all about the virtual machine on a server. Here's what the same setup looks like when you're using Docker containers. Here, you'll notice that there are a lot fewer layers. Docker doesn't require a bunch of massive guest operating systems. Let me break it down from the bottom up again. Infrastructure and host operating systems are the same as we discussed for the virtual machine. Coming into the third layer, instead of a hypervisor, Docker uses Docker Engine. Docker Engine or Docker is a client-server application that builds and executes containers using Docker components. Next, we have our dependencies. Just like on the virtual machines, here dependencies are built into a template called Docker images. As you can see on the screen, each application is still isolated and occupies less space. Now, let's have a look at the significant differences between Docker and virtual machine. Let's start with the operating system first. Docker is a container-based model where containers are software packages used for executing an application on any operating system. On the other side, virtual machine is a container-based model. It utilizes user space along with the kernel space of the operating system. A kernel space is where the core of the operating system runs and provides its services to the user. A user cannot modify this space, and user space is the portion of the system memory in which the user's processes run. Docker containers share operating system kernels with other applications and result in a higher server efficiency. Hence, Docker provides the most substantial default isolation capabilities among the other configuration tools. On the other hand, virtual machines do not share the operating system. Also, it does not provide isolation in the host kernel. In Docker, multiple workloads can run on a single operating system. But in virtual machine, each workload needs a complete operating system or a hypervisor. The next significant difference between the two is the performance. In the case of Docker, they use the same operating system without any additional software like hypervisor. In case of virtual machines, performance issues are a major problem. It can be due to the several reasons like CPU constraints, memory allocation, network latency, and many more. Running multiple virtual machines lead to an unstable performance. Docker containers can start up quickly and result in less boot-up time, whereas virtual machines do not start quickly and lead to a poor performance. Now, let's talk about the next difference, which is portability. With Docker containers, a developer can build an application and store it into a Docker image. Later, he or she can run it across any host environment. But when it comes to virtual machines, it has portability issues. Virtual machines do not have a central hub like Docker does, and it requires more memory space to store data. Docker containers are smaller than virtual machines, due to which the process of transferring files on the host file system is easier. On the other hand, dependency on the host operating system and hardware makes virtual machines less portable. While transferring files, virtual machines should have a copy of the operating system and its dependencies, due to which image size is increased and becomes a tedious process to share data. The boot-up time between the both is very different. The application in Docker containers start without any delay since the operating system is already up and running. On the other hand, virtual machines take much longer time than it takes for a container to run applications. These containers were basically designed to save time in the deployment process of an application, whereas in virtual machines, to deploy a single application, virtual machine needs to start an entire operating system, which would result in a full boot process. So those were the major differences between Docker and a virtual machine. Now let's discuss the minor differences between them. Docker is not always in a running state. It stops when the stop command is executed, whereas The virtual machines are always running in the background, which will result in huge RAM consumption. Talking about snapshots. Docker has a lot of snapshots. A snapshot is an image that you can upload on a private repository to access it on another host. But virtual machines do not consist of any snapshots. In Docker, images can be version controlled just like Git. They have local registry called Docker Hub where users store and distribute container images. On the other hand, virtual machine does not have a central hub. They are not version controlled. Docker can run multiple containers on a system. Users can connect multiple containers using user-defined networks and shared volumes. Multiple containers can be accessed on the same machine and share the operating system kernel with other containers. Each container is isolated in user space. Also, Docker containers occupy less space than virtual machines and start instantly. Virtual machine can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Multiple containers can be started at a time on the Docker engine. The isolation environment allows a user to run and deploy several containers simultaneously on a given host. Virtual machines can run only a limited number of virtual machines on a system. Since each virtual machine requires a certain amount of CPU, RAM, memory, and other resources, your physical systems will have less space. Now that I have told you the differences between Docker containers and virtual machines, let me show you a real-life case study of how BCC uses Docker. BCC News is a British news channel over 500 developers working across the globe. BCC News delivers broadcasts in almost 30 different languages and with over 80,000 daily news in English alone. The news channel ran more than 26,000 jobs with more than 10 continuous integrations with sequential scheduling. The company had issues with identifying a way to unify the coding process and monitor the continuous integration consistently. Also, the existing jobs took up to more time, that is, up to 60 minutes to schedule and perform its task. Docker allowed BCC News to eliminate job wait times and run jobs in parallel. It also gave the users the ability to work in a more flexible CI environment where entire code processes were unified and stored in a single place. However, Docker succeeded in spreading up the whole continuous integration process.
So if you are looking to become a Docker expert, consider the postgraduate program in DevOps by Simplilearn to gain expertise in Docker. This program offers blended learning that combines live online DevOps certification classes with interactive labs that will give you hands-on experience. You will gain expertise in the tools like Terraform, Maven, Ansible, Jenkins, Docker, JUnit, Git, and more. We prefer 1 year of prior experience to enroll in this course. So why wait? Enroll the course from the link in the description box.
So let's go through, and you're going to be asked to explain what the architecture of Docker is. And Docker really is the most popular containerization environment. So Docker uses a client-server architecture. The Docker client is a service which runs in a command line. And then the Docker daemon, which is run as a REST API within the command line, will accept the requests and interacts with the operating system in order to build the Docker images and run the Docker containers. And then the Docker image is a template of instructions which is used to create containers. The Docker container is an executable package of applications and its dependencies together. And then finally, the Docker registry is a service to host and distribute Docker images among other users. So you'll also be asked to provide what are the advantages of Docker over virtual machine. And this is something that comes up very consistently. In fact, you may want to even extend it as having what are the differences between having a dedicated machine, a virtual machine, and a Docker or Docker-like environment. And really, the arguments for Docker are just absolutely fantastic. First of all, Docker containers occupy significantly less space than a virtual machine or a dedicated machine. The boot up time on Docker is significantly faster than a VM. Containers have a much better performance as they are hosted in a single Docker image. Docker is highly efficient and very easy to scale, particularly when you start working with Kubernetes. Easily portable across multiple platforms, and then finally, For space allocation, Docker data volumes can be shared and reused among multiple containers. The argument against virtual machines is significant, and particularly if you're going into an older environment where a company is still using actual dedicated hardware and haven't moved to a cloud or cloud-like environment, your arguments for Docker are going to be very, very persuasive. Be very clear on what the advantages are for Docker over a virtual machine, because you want to be able to succinctly share them with your team. And this is something that's important when you're going through the interview process, but also equally important, particularly if you're working with a company that's transitioning or going through a digital transformation where they aren't used to working with tools like Docker. You need to be able to effectively share with that team what the benefits are. So how do we share Docker containers with different nodes? And in this instance, what you want to be able to do is leverage the power of Docker Swarm. So Docker Swarm is a tool which allows the IT administrators and developers to create and manage clusters of Swarm nodes within the Docker platform. And there are two elements to the node. There's the manager node, and then there's the worker node. The manager node, as you'd assume, manages the entire infrastructure, and the worker node is actually the work of the agent as it gets executed. So what are the commands to create a Docker Swarm? And so here we have an example of what a manager node would look like. And once you've created a swarm on your manager node, you can now add worker nodes to that swarm. And again, when you're stepping through this process, be very precise in the execution part that needs to be taken to be able to effectively create a swarm. So start with the manager node, and then you create a worker node. And then finally, when a node is initialized as a manager node, it can immediately create a token, and that token is used for the worker nodes and associating the IP address with the worker nodes. Question 17, how to run multiple containers using a single service. It is possible to run multiple containers as a single service by using Docker Compose. And Docker Compose will actually run each of the services in isolation so that they can interact with each other. The language used to write out the compose files that allow you to run the service is called YAML, and YAML stands for yet another markup language. So what is the use of a Docker file? So a Docker file actually is used for creating Docker images using the build command. So let's go through and show on the screen what that would look like. And this would be an opportunity where if you're actually in a technical interview, you could potentially even ask, hey, can I draw on a whiteboard and show you what the architecture for using the build command would look like and what the process would look like? Again, when you're going through an interview process, as someone who interviews a lot of people, one of the things that I really like is when an interview candidate does something that's slightly different. And in this instance, this is a great example of where you can stand up to the whiteboard and actually show what can actually be done through actually creating images on the whiteboard very quickly, little square boxes where you can actually show the flow for creating a build environment. As an architect, this should be something that you are comfortable doing, and by doing it in the interview, and certainly you want to ask permission before you actually do it, but doing this in the interview really helps demonstrate your comfortable feelings of working with these kind of architecture drawings. So back to the question of creating a Docker file. So we go through and we have a Docker file that actually then goes ahead and creates the Docker image, which then in turn creates the Docker container. And then we are able to push that out up to a Docker Hub and then share that Docker Hub with everybody else as part of the Docker registry with the whole network. So what are the differences between Docker image and Docker containers? So let's go through the Docker image. So the Docker images are templates of a Docker container. An image is built using a Docker file, and it stores that Docker file in a Docker repository or a Docker Hub. And you can use Docker Hub as an example. And the image layer is a read-only file system. The Docker container is a collection of the runtime instances of a Docker image, and the containers are created using Docker images, and they are stored in the Docker daemon, and every container is a read-write file system. So you can't replace the information, you can only append to it. So while you can actually use YAML for writing so a question you're going to be asked is, instead of YAML, what can be an alternate file to build Docker Compose? So YAML is the one that is the default, but you can also use JSON. So if you are comfortable working with JSON, and that is something that you should be get comfortable with, is You want to be able to use that to name your files. And as a frame of reference, JSON is a logical way of being able to do value paired matching using a JavaScript-like syntax. So you're going to be asked to how to create a Docker container. So let's go through what that would look. And we'll break it down task by task. So the task is going to be create a MySQL Docker container. So to do that, you want to be able to build a Docker image or pull from an existing Docker image from a Docker repository or hub. And then you want to be able to then use Docker to create a new container, which has MySQL from the existing Docker image. Simultaneously, the layer of read-write file system is also created on top of that image. And below at the bottom of the screen, we have what the command lines look for that. So what is the difference between a registry and a repository? So let's go through that. So for the Docker registry and repository, for the registry, we have Docker registry is an open source server-side service used for hosting and distributing Docker images. Whereas in contrast, for repository, it's a collection of multiple versions of a Docker image. In a registry, a user can distinguish between Docker images with their tag names. And then finally, on the registry, Docker also has its own default registry called Docker Hub. For the repository, it is a collection of multiple versions of Docker images. It is stored in a Docker registry, and it has two types, a public and private registry, so you can actually create your own enterprise registry. So you're going to be asked, what are the cloud platforms that support Docker? Really, list them all. We have listed here Amazon Web Services, Microsoft Azure, Google Cloud, Rackspace. But you could add in there IBM, Bluemix. You could put in Red Hat. Really, any of the cloud service providers out there today do support Docker. It's just become an industry standard. So what is the purpose of expose and publish commands in Docker? So if we go through, expose is an instruction used in Dockerfile, whereas publish is used in Docker run command. For expose, it is used to expose ports within a Docker network, whereas with publish, it can be used outside of a Docker environment. For expose, it is a documenting instruction used at the time of building an image and running a container, whereas with publish, it is used to map a host port to a running container port. For expose is the command used in Docker, whereas for publish, we use the command -p for when we're doing our command line used in Docker. And examples of these are expose 8080, or with Docker, we would put in, or for publish, we would do the example Docker run -d-p and then 0.0.0.80 as our command line.
So here we wrap up Docker Complete course. So if you like this video, consider subscribing to Simplilearn to stay updated with DevOps technology. Thanks for watching.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.